Hello. Okay, So, magandang hapon sa lahat. Okay, teka wait, adjust lang natin ang ayan. Okay, so good afternoon everyone. Okay, so I hope nandito naman na lahat. So, we'll be starting off the clinical chemistry discussion, continuation to where we left off last Thursday. Okay, so we'll be having still clinical chemistry. And I think for those who are getting lost, I think we're on page number 5. Okay, tama pa. Page number 5 nung ating notes. Okay, so I think we're still on laboratory mathematics and may mga naiwan pa tayong computation. So I think we're on item number 14. Please correct me if I'm wrong. Okay, pero ayan, I think we're on item number 14. Okay, and ito yung question about it. Okay, so let's try to read on the question first, no? Okay, so we have this one. Ay, 10 pa lang pala, sorry. Okay, 10 pa lang ba? Ay, yung, sorry, akala ko item 14. Saan bang lupalop ako naligaw? Okay, teka. Tama, item 10 pa lang? Okay, sorry. Teka, asa ba item number 10 natin? Item number 10? Teka. Ay, okay. So, sa iba sa ibang school ata yun. Sorry. Ayan, thank you po sa pag-message. Okay, ito yung item number 10 natin. Okay. Yung modified version ng normality natin. Sorry, panic mode ako. Okay, so either way, we'll be having item number 10. Okay, so number 10. So I think we're still on page number 4 pa. Okay, ng ating notes. Okay, pero let's try to read on the problem muna. Okay, so how many grams daw of sulfuric acid would be weighed to prepare 2 liters of your 4 normal na sulfuric acid. Okay, so this is still a question no, that concerns normality, pero medyo thwarted yung question kasi binigay si normality. Binigay din yung volume or yung liter ng solution natin. So, ang tinatanong sa atin is yung grams. Okay, how many grams of sulfuric acid daw would be needed. So how are we supposed to face this formula or this problem particularly? So actually, we will still be using the same formula. Okay, formula pa rin naman tayo ng normality. Okay, medyo i-derive lang natin siya ng konti. Pero dito, normality na formula pa rin naman yung gagamitin natin. So recap nga natin, ano na nga ba yung formula natin ng normality? 'Di ba normality, sulat lang natin. Normality is equivalent to the, again, ingat kayo sa unit, grams ng ating solute. I-divide down natin, okay, i-divide down natin with the molecular weight. Okay, so molecular weight ng ating solute. And syempre, bago natin yon i-multiply sa liter ng solution, since we are talking about normality, we will have to first divide it with the valence bago natin siya i-multiply with the liter of the solution. Okay, so ito yung formula natin last time no, ng ating normality. Okay, so this time, let us try to substitute. No? Substitute natin yung given on the equation. Okay, so let's try to substitute the given on the equation. So, ano ba yung given sa atin? Okay, so in this case, given sa atin si normality. Okay, and looking at it, ano daw yung normality ng ating solution? Okay, 4 normals yung ating solution. So, substitute natin dun sa normality is 4. 4 normals daw yung ating solution. Tapos, anong ilalagay natin sa grams ng solute? Since hindi pa natin alam, tinatanong pa lang siya sa atin how many grams. So, we don't have an idea yet kung gaano kadami yung grams ng ating solute. So, siya yung ating magiging misteryosong X. Okay, ito yung pinapahanap sa atin. We are being asked about the grams of the solute. Okay? Tapos, i-divide daw natin sa molecular weight ng ating solute. Pero before that, ilagay na natin yung liters. Ano? Binigay naman yung liters ng ating solution. So, ang liters ng ating solution ay 2 liters. So, lagay na natin si 2 dito sa liter of the solution. So, ang malaking problema natin is wala pa tayong molecular weight. Okay, wala pa yung molecular weight ng ating solute. Okay, minsan binibigay na yung molecular weight ng solute, pero sometimes they would just give you the atomic weights, which I actually forgot to insert on your notes. Okay, so paki-add na lang no, dun sa notes natin yung mga corresponding atomic weights ng ating mga elements. Okay, again, no need for you to memorize the periodic table of elements. No need for you to memorize the atomic weights kasi usually given naman to. I just forgot to put it on your notes. Okay, pero usually given naman yung atomic weights natin. Okay, so lagay na rin natin dito. Ang hydrogen natin has an atomic weight of 1. Ang sulfur natin has an atomic weight of 32. And yung oxygen natin has an atomic weight of 16. Okay, we are asked to look for the molecular weight. Okay, kaso ang bigay pa lang sa atin ay mga atomic weights. Again, paki-add lang sa notes natin kasi hindi ko siya na-insert. Pero don't worry ha, usually given naman na to. Usually the atomic weights are already given. That's why, again, no need for you to memorize the periodic table of elements. Okay? So dito, let us try to calculate no, the molecular weight. Okay, molecular weight ng ating sulfuric acid. So, molecular weight of your sulfuric acid. Remember, sulfuric acid is H2SO4. Okay, so sulfuric acid is H2SO4. So, what makes up your sulfuric acid? Sulfuric acid is made up of hydrogen. They're also made up of sulfur and they also contain oxygen. Now, ingat sa pagbibilang ng number ng atoms. Ilang pirasong hydrogen meron dun sa ating sulfuric acid? Ang sulfuric acid natin, meron 2 pirasong hydrogen. Ilang pirasong sulfur ang meron siya? Yung sulfur natin, walang subscript, so that would automatically be equivalent to 1. And yung oxygen natin ay 4 pieces. Okay, so 4 pieces yung ating oxygen. So again, ingat sa pagbibilang ng number ng atoms kasi diyan madalas nadadala yung mga students, no? So kapag walang nakalagay sa subscript, that's automatically equivalent to 1. Okay? Tapos i-multiply lang din now natin sila with their corresponding atomic weights. So again, given naman na yung atomic weights, hindi ko lang siya nailagay sa notes natin. So kindly copy the ones on the chat box natin. Hydrogen has an atomic weight of 1. Ang sulfur natin has an atomic weight of 32. And yung ating oxygen has an atomic weight of 16. Okay, tapos multiply lang naman natin sila. 2 times 1 would give us 2. 1 times 32 would give us 32. And then syempre 4 times 16 would give us 64. Ito total lang naman natin sila, no? So we have 32 plus 2 plus 64. That would give us a total of 98. So therefore, ano daw palang molecular weight ng sulfuric acid natin? Sulfuric acid no will have a molecular weight of 98. Okay, so 98. So again, yung number ng atoms
Minultiply lang natin sa corresponding atomic weights. And again, yung atomic weights nilagay natin sa chat box for your reference. Pero again, usually given yung atomic weights pagdating ng exam. Now, that's why you don't need to memorize the periodic table of elements. Minsan nga, in fact, hindi na nila ipapakompute si molecular weight. May mga instances kasi na given na si molecular weight. Okay, kaso since ang binigay pa lang sa atin ay mga atomic weights, we had to calculate pa the molecular weight of sulfuric acid. So again, multiply lang natin yung number ng atoms with their corresponding atomic weights, tas i-add mo lang silang lahat, 2 plus 32 plus 64, that would give us 90. Okay, so 98 ang ilalagay natin sa molecular weight ng ating sulfuric acid. Again, sulfuric acid is H2SO. Okay? Tapos, anong gagawin natin sa molecular weight? The molecular weight must first be divided with the valence. And can you still remember how to get the valence? Valence is the subscript of the first element. Sino nga ulit yung first element natin? First element natin is hydrogen. The subscript thereof is 2. Therefore, ang valence ng sulfuric acid will be equivalent to 2. Okay? So, ito na ngayon yung magiging working equation natin. So, this would now be our working equation. Okay, so anong gagawin natin? Remember, kapag may magkamukha sa numerator at sa denominator, what happens? Usually, kapag may magkamukha no, sa numerator at sa denominator, tendencies they would get canceled out. So, ang may iwan na lang will be 98. Okay, so kung i-rewrite natin yan, meron tayong 4 is equal to x over 98. Okay? However, para balanse, gawin nating fraction. Fraction yung nasa left side, fraction yung nasa right side. How do we make 4 a fraction? Paano natin gagawing fraction si 4? Lalagyan mo lang siya ng over 1 para maging fraction siya. Ma'am, bakit ginawa mo siyang fraction? Well, para magawa natin yung crisscross or cross multiplication. Remember, magagawa lang kasi natin si cross multiplication kung fraction yung nasa left side at fraction yung nasa right side. So, ginawa nating fraction si 4. Paano natin gagawing fraction si 4? Gawin mo lang siyang 4 over 1. Okay, so over 1 para magkaroon ka ng fraction sa left, fraction sa right side, equal sign in the middle. Again, the most logical thing to do would now be the crisscross or cross multiplication. So that means we have 1 times x at saka equals daw to 4 times 98. So, i-write natin yung ating equation. So, we have 1 times x. Any number multiplied by 1 will still give us the same number. That will still give us the x. And this is equivalent to 4 times 98 on the other side of the equation natin. Okay, and what is 4 multiplied by 98? So, this would, I think, give us 392. Okay, pero syempre, let me try to use a calculator on it. Okay, medyo may trust issues lang ako sa math ko. Okay, pero ayan. Let's try to put out some sort of calculator. 4 times, okay, where's the times? 4 times 98. Ayan, so it gave us 392. So therefore, to answer the question, how many grams daw? How many grams daw ng sulfuric acid would be needed to prepare 2 liters of the 4 normal na sulfuric acid? To prepare 2 liters of a 4 normal na solution, you will have to use 392 grams. Okay, so 392 grams. So therefore, for item number 10, the final answer natin will be 392. Okay, so item number 10, we have 392. Okay, so again, kung titingnan nyo, same formula pa rin naman tayo. We still use the same formula, pero yun nga lang, ang pinahanap sa atin ay grams of solute. Furthermore, hindi pa given si molecular weight, which made things a bit complicated kasi we had to calculate muna the molecular weight. Calculate the molecular weight before nating magamit yung formula natin. Okay, pero still, we ended up on the same na equation or same na result. We have 392. Okay, so 392 for item number 10. Okay, so I hope clear naman itong si item number 10 natin. Okay, so kapag may questions ha, please do inform me. Okay, pero in here, proceed tayo to the next item natin. So next item, we have item number 11. Okay, so item number 11, let's try to look at how the item number 11 works. Okay, so before that, basahin muna natin yung problem. Okay, so let's try to read first the problem concerning item number 11. Okay, so ito yung ating item number 11. Okay, a serum sample, by the way, this one was a recall question, an exact recall question. A serum sample daw shows a chloride concentration of 500 milligrams per 100 ml. And we are asked to convert it into milli-EQ per liter. So we are asked about kung ano yung magiging value niya in milli-EQ per liter. Okay, milli-EQ per liter, can you still remember how we get the milli-EQ per liter? Milli-EQ per liter, ito yung milli version ng normality natin. So this is in fact the milli version of your normality. So therefore, paano nga natin kinukuha yung milli version ng normality? So normality formula pa rin naman, pero maglalagay ka lang ng milli sa numerator. Milli sa numerator, so mag-a-add tayo ng milli sa numerator ng left side, maglalagay ka rin ng milli sa numerator sa right side ng equation. Kaya instead of using grams of solute, we will be using milligrams of solute instead. Okay, pero again ha, walang magbabago sa denominator, walang magbabago sa denominator kasi ang nilagyan lang naman or pinalitan lang naman natin is yung nasa numerator ng left side. So para balanse, numerator lang din ng right side yung papalitan naman natin. So we will have to use milligrams ng solute instead of the grams ng solute. Tapos, walang magbabago sa denominator ha. Molecular weight pa rin over the valence and imumultiply lang natin with the liter. Liter pa rin ha of the solution. Okay? So in this case, substitute natin yung given on the equation. We're asked to get the milli-EQ per liter. So anong gagawin natin? Lagay daw natin yung milligrams ng solute. Ilan daw ba yung milligrams ng solute natin? Milligrams ng chloride natin is 500. So let's put 500 on the numerator. And i-divide daw natin siya with the molecular weight. Hindi ko sure kung nailagay ko dyan yung molecular weight. Okay, pero dito, ang pinapahanap sa atin ay chloride. Kaso I think wala yata yung atomic weight ng chloride dyan. So paki-add na lang dun sa ating notes. Again, usually binibigay na to ha. Nakalimutan ko lang talaga siyang i-insert dun sa problem natin. Pero the atomic weight of chloride, okay, lagay natin sa chat box. Atomic weight ng chloride is 35.5. Okay, again, this is usually given. I just forgot to put it on your notes. Okay, pero atomic weight ng chloride natin is 35.5. Okay? And since chloride lang naman to, wala siyang kasama, as is, yung atomic weight will be equivalent to the molecular weight na rin natin. Okay? Ang chloride naman, Cl lang naman yan. Wala siyang kasamang iba. Ang chloride natin will be Cl, wala siyang ibang kasama. So therefore, yung atomic weight mo would practically be the same as the molecular weight natin. Okay, so let's try to put the molecular weight in here or the atomic weight in here. Dito sa molecular weight, lalagay natin 35.5. Okay? 35.5 ang ilalagay natin in here. I-divide daw natin siya with the valence. Okay? Ano bang valence ng chloride natin? Ang chloride natin is practically Cl. Siya lang mag-isa. Wala siyang ibang kasama. And since wala siyang subscript, subscript of the first element, no? So siya na yung first element. And wala siyang subscript, so that's practically equivalent to 1. Okay? So ang valence niya would be equivalent to 1. Okay? So valence is 1. Kasi chloride, Cl lang, walang subscript. Okay, so siya lang din naman mag-isa. So valence niya would be equivalent to 1. Multiply daw natin with the liter of the solution. Kaso ingat kayo ha, anong binigay sa atin? Ang binigay sa atin ay ml. So we have to first convert that into liters. 100 ml, kung gagamitin natin yung conversion factor natin, 1 liter is equivalent to 1,000 milliliters. Ito yung conversion factor natin. Ang 100 ml natin would then be equivalent to 0.1 liters. Okay, so instead of 100 ml ha, ang gagamitin natin ay 0.1 kasi we are asked to use the liter of the solution. Okay, so liter of the solution, 100 ml. 100 ml is equivalent to 0.1 liters. Okay, so ito na ngayon yung working equation natin. Let's try to solve it out. Milli-EQ per liter, milli-EQ per liter. So, milli-EQ per liter, okay, ano mangyayari? We have 500 on the numerator. Divide natin by 35.5 over 1 would give us 35.5. Multiplied by 0.1, that would give us 3.55. Okay, and what is 500 divided by 3.55? So, let me check it out. 500 divided by 3.55, that would give us 140.85. I-round off na natin. 140.85 milli-EQ per liter. Okay, so therefore, final answer natin in here would be equivalent to 140.85 milli-EQ per liter. So again, if you're not arriving on the exact answer sa mga choices, try choosing the closest. The closest. Final answer will be 140.85 ni-round off na natin to the nearest whole number. And ang unit natin is milli-EQ per liter. Okay, so we have 140.85 milli-EQ per liter. Okay, so again, this is just a normality problem pa rin naman. Yung formula natin, normality pa rin naman siya. Minodify lang natin kasi ang normality EQ per liter. Kaso ang pinapahanap sa atin ay milli-EQ per liter. So therefore, we added milli on the numerator ng left side at saka ng right side. Pero still, it is your formula for normality pa rin that we use. Okay, ginawa lang nating milli version ng normality. Okay, so still we have the final answer. For item number 11, we have 140.85 milli EQ per liter. Okay? So, yan yung ating item number 11. So, I do hope nasusundan naman. So, again, hindi ko lang yata nailagay yung atomic weight. Okay, ang atomic weight ng chloride again is 3.55. Okay, sorry, 35.5 rather. Okay, 35.5. Okay, so again, usually given naman na. Usually given naman na yung ating atomic weights. Okay, hindi ko lang talaga siya na-insert dyan sa notes natin. Okay, pero usually given naman na siya. Okay, so you really won't need to memorize the periodic table of elements. Okay, pero still for item number 11, we got 140.85 as the best possible answer. Okay, now what about item number 12? Okay, let's try to look at item number 12. Okay, so punta natin si item number 12. We have this one. Okay, item number 12. Okay, so dito we are asked, what is the equivalent molarity of a 0.5 normal na sulfuric acid? So we are asked to directly convert. Pinapa-convert sa atin si normality into molarity without any other given. Okay, so ano ba yung shortest possible way to convert molarity into normality and vice versa? So for that, we will be using this formula, no? If you want to get the molarity, all you have to do is to use the normality, di-divide mo lang siya with the valence. Okay, as simple as that. Molarity, para daw makuha natin si molarity, you just have to use normality, divide lang daw natin with the valence. Okay, so that means we have to get the molarity. Ang normality natin ay 0.5, i-divide daw natin with the valence. And ano nang ang valence ng sulfuric acid natin? The valence of your sulfuric acid is 2. So that would give us 0.5 divided by 2. And what is 0.5 divided by 2? That would give us 0.25. Okay, so yung shortcut no on how to get the molarity if normality yung given. So for item number 12, your best possible answer will be 0.25 molars ng ating solution. Okay? Ma'am, what if it's the other way around? What if we are asked to get the normality? How are we supposed to derive the formula ng normality? So if you want to get the normality naman, pag i-derive mo yan, molarity lang, multiply mo lang with the valence. Okay, so to get naman the normality, molarity lang, multiply mo lang directly with the valence. Okay, pero dito, since molarity ang pinapahanap sa atin, that would be equivalent to normality divided by the valence. Okay, so therefore again, for item number 12, no, the best answer will be 0.25 molars ng ating solution. Okay, so number 12, we have 0.25. Okay, what about item number 13? Okay, so let's try to look at item number 13. Okay, now, si item number 13, ang pinaka-frequent na question pagdating sa clinical chemistry. Pero watch out kasi itong question na to, sometimes makikita nyo to sa histotech. Okay, ano ba tong question number 13 natin? Okay, basahin muna natin si question number 13. Okay, question number 13 is like this. How much 95% alcohol daw is necessary to make 200 ml of the 5% na alcohol? Okay, ma'am, paano mo nasabing frequent na question yan? Okay, so how did we say that this is a frequent na question? Minsan tinatanong to sa histotech. Kasi typical problem to sa laboratory, no? Ito ang kailangan mo. Kaso ito lang ang meron. Okay, typical problem in the laboratory. Ang kailangan mo daw ay 5% alcohol. Kaso ang available lang ay 95%. Okay, what you need is a 5% alcohol but ang available lang ay 95%. So, paano ka mag-a-adjust? Paano tayo mag-a-adjust? So, for this one, we will be using the formula C1V1 is equal to C2 V2. Okay, so we will be using the formula C1V1 is equal to C2 V2. Ano ibig sabihin ng C1V1 at saka C2 V2? Okay, concentration number 1 multiplied by the volume number 1 is equivalent daw to the concentration number 2 multiplied by the volume number 2. Okay, so multiply lang daw natin with the volume number 2. So the next question now is, ma'am, sino si V1, sino si C1, sino yung magiging C2, sino yung magiging V2 natin? Okay, so to make things easier, ganito. Ang gagawin natin, kung sino yung kauna-unahang concentration na makikita mo sa problem, siya ang gagawin nating C1. Okay, so yung kauna-unahang concentration na makikita mo sa problem, siya ang gagawin natin C1. Okay, so based dun sa question natin, sino ba yung kauna-unahang concentration na nakita natin? So the first concentration that we have in here or that we ever saw on the problem is 95. So total siya naman yung unang concentration. Let's make it your C1. Okay? Tapos, kada concentration may ka-partner silang volume. The next question is, sino yung volume partner ng C1 natin? Sino daw ba yung volume na ka-partner ng ating C1? Okay? C1, gaano kadami? Yung C1, gaano kadami yung volume ng 95 natin? The answer is, hindi pa natin alam. Kasi they are still being asked problem natin. So, kung titingnan niyo yung question, no, how much 95%, gaano kadami yung volume ng 95% alcohol. So, hindi pa natin alam yung volume ng 95% alcohol. So, therefore, your V1 will be the mysterious X natin. Okay, so siya yung X na hahanapin natin. Okay, so dito we have the 95% as the first concentration that we ever saw on the problem. And since hindi pa natin alam kung gaano kadami yung 95%, yung volume na kapartner ni 95% will be equivalent to the X. Okay? And this is now equivalent to the concentration number 2. Sino ba yung concentration number 2? Sino ba yung pangalawang concentration na nakita natin sa problem? 5%. So let's make it your C2. Okay, so siya yung magiging concentration number 2 natin. At sino yung volume na kapartner ng C2 natin? Okay, sino yung volume partner ng C2 natin? Etong 200 ml. Okay, so 200 ml will serve as your volume number 2. Ma'am, paano nga pala namin malalaman kung sino yung magka-partner? How would we know, ma'am, kung sino yung tamang magka-partner? Hindi kasi pwede magkapalit ng ka-partner, ha? Magkakagulo ang Pilipinas kapag nagkapalit sila ng magka-partner. So, ma'am, how would we know kung sino yung tunay na magka-partner? Simple lang. The easiest way to do that is by looking for the magic word. At ang magic word natin ay off. Hahanapin nyo palagi yung off. Usually, yung off sa mga ganyang problem, they're always surrounded by numbers. Kadalasan, no, yung off sa mga ganitong klaseng problem, kadalasan may number yan sa left side, may number siya sa right side. And yung clue natin is yung off, automatic kung sino yung nasa left and side, left and right nung off na word, automatic sila yung tunay na magka-partner. Okay, so let's try to look at the problem natin. So kung titingnan natin, nasan yung word na off? Ito yung off natin, no? May number siya sa left, may number siya sa right side. So sila yung magka-partner. Okay, so therefore, sure tayo na ang ka-partner ni 200 ml will be 5%. Just don't forget to look for the magic word, ha? The magic word natin is the word na off. Okay, so ito na ngayon yung working equation natin. We have 95 times x is equal to 5 times 200. Let's try to simplify it out. We have 95x on the left side and 5 times 200 on the right side. 5 times 200 would give us 1,000. Okay, and anong gagawin natin? Kung titignan nyo, 95x, di ba hindi pwedeng may kasama yung x? Kailangan your x should always be alone. Eh kaso may kasama siyang 95 at multiplication yan. Remember ang rule natin, pag multiplication, do the opposite. Anong opposite ng multiplication? Division. So anong gagawin natin to get rid of 95? I-divide mo lang siya sa sarili niya. Di-divide mo lang din siya with 95. Kasi remember, pag may 95 sa taas, may 95 sa baba, they would get canceled out. They would get canceled out. At may iwan ang x mo na nag-iisa at luhaan. Okay, however, everything in life has to be balanced. Whatever you did on the left side, you need to do the same exact thing on the right side. So kung yung left side ay dinivide mo by 95, dapat balance. You also have to divide the right side with 95. So that means your x is equal to 1,000 divided by 95. And what is 1,000 divided by 95? That would be equivalent to 10.53. Okay, so 10.53 ml. Okay, so therefore, what would now be the final answer natin for item number 13? For item number 13, no, the best answer will be 10.53. Okay, 10.53 ml. Okay, so therefore, wag kakalimutan yung formula natin. C1V1 is equal to C2. Ang gagawin lang natin, hahanapin lang natin yung word na off. Okay, kasi yung word na off ang magsisilbing clue para malaman mo kung sino yung tunay na magka-partner. So in this case, ito yung off na word natin. May number sa left side, may number sa right side. Therefore, magka-partner si 200 at saka si 5%. Okay, so therefore, for that item number 13, the final answer now will be 10.53. Okay, so 10.53 ml. Okay, so I do hope nasusundan pa. Okay, now let's go to the most complicated problem of all time. The most complicated, the most intimidating, and scariest problem that you may encounter sa board exam, itong next na problem natin, ano, si item number 14. Okay, let's try to look at item number 14 muna. Okay, so item number 14, okay, we have this one. Okay, let's try to read on the problem muna. Okay, so na si item number 14 natin. Item number 14, we have this one. Okay? If directions for a reagent specify 8.0 grams ng sodium sulfate na anhydrous, tapos ang available lang daw na salt ay sodium sulfate decahydrate. Okay, so decahydrate meaning meron siyang 10, deca means 10, 10 water na molecule. Okay? Typical problem sa laboratory, no? Ito, ang kailangan ay anhydrous. Kaso, ang available lang ay hydrated. Okay, ang available lang ay sodium sulfate na may tubig, sodium sulfate na hydrated. So, ngayon, ang tanong sa atin, gaano kadami? How much of the hydrated salt will you use? Okay, gaano daw bang kadaming hydrated salt ang gagamitin natin? Okay? So naalala ko itong question na 'to 'no, ito yung isa sa mga kinatatakutan kong problem. Ako personally, kinatatakutan kong problem dati 'no, pagdating sa mga exam. Okay, mapa-board exam, mapa-mock board, okay, mga mock board sa school, assessment exams sa mga school, ganyan. Yan yung 'pag nakita ko yung word na anhydrous, auto skip yan sa akin. Dati nung student ako 'no, auto skip yan, okey. Usually 'pag nakita ko ng mga words na anhydrous, hydrated, ay ayoko na niyan, tatalon na ako sa susunod na problem. Okay, tapos ta-try ko na lang siyang hulaan. Ta-try ko na lang siyang hulaan 'no, at the end of the exam. Okay, pero kung papansinin niyo mukha lang siya nakakatakot. Pero in reality, ratio and proportion lang pala yan. Yung mga problems natin about the hydrated and anhydrous are actually solvable by simple ratio and proportion. Okay, ma'am, how simple would that be? Latag muna natin yung formula. Okay, so latag muna natin yung ating formula. Ang formula pala nito ratio and proportion lang. Okay, ratio and proportion ng alin, ma'am? Okay, sige tayo. We will be using the alin. Ay, sorry. We will be using the grams. Okay, doon lang tayo maglagay ng formula. Grams ng hydrated, i-divide lang daw natin dun sa grams ng anhydrous. So, i-ratio lang natin siya, no? With the grams of the anhydrous. Tapos, ipo-proportion. So, equal lang. So, dito ni-ratio natin, no? So, dito ni-ratio natin yung grams ng hydrated over the grams of the anhydrous. So, ratio yan. Tapos, ipo-proportion. Kaya equal. Ipo-proportion lang daw natin siya with what? Ipo-proportion lang natin siya dun sa alin? Dun sa molecular weight. Molecular weight ng hydrated pa rin yung nasa numerator. Hydrated nasa numerator. Di-divide natin with the molecular weight. Molecular weight ng ating anhydrous. Okay, so yan yung formula natin. Okay, formula natin. Again, this is in fact just a ratio and proportion. Okay, ratio and proportion lang siya. Again, i-ratio daw natin. I-ratio lang natin yung grams ng hydrated over the grams of the anhydrous. Tapos, ipo-proportion lang natin siya, equal sign, with the molecular weight of the hydrated over the molecular weight of the anhydrous. Okay? Try nating i-substitute yung nag-iisang given natin dito sa equation. Napansin nyo ba sa problem natin, nag-iisa lang yung given natin?
The only given that we have in here is 8.0 grams. So question, where are we supposed to put the 8.0 grams? 8.0 grams daw ay grams ng anhydrous sodium sulfate anhydrous. So dito natin siya ilalagay, oh. Grams ng anhydrous, 8.0 grams. So try natin i-substitute. Lagay natin dito. Yung 8.0 or 8, ilalagay natin sa denominator, left side ng ating equation. Okay? What about the grams of the hydrated? Anong ilalagay natin sa grams of the hydrated? Kung titingnan nyo dun sa dulo, oh, how much of the hydrated salt will you use? Hindi pa natin alam kung gaano kadami yung hydrated salt. So, tinatanong pa lang sa atin yung dami, yung grams, yung dami in grams ng hydrated salt natin. So, hindi pa natin alam. That means the grams of the hydrated salt natin will be the mysterious X natin. Okay? So, siya yung ating magiging misteryoso X. Okay? So, tinatanong pa lang siya sa atin, ha? How much daw kasi? Gaano kadami yung hydrated salt? So, di pa natin alam. Siya yung ating magiging X in here. Okay? And this is equal daw. Ito ngayon yung malaking problema, no? This is ipoproportion daw natin to sa molecular weight. Kaso ang problema, walang binigay na molecular weight. So, ito yung nagpa-complicate sa problem na to. Magko-compute ka pa kasi ng molecular weight. So, we had to compute the molecular weight of the hydrated and molecular weight pa ng anhydrous. Again, ang mga atomic weights are usually given na, kaso hindi ko sure kung nailagay ko na naman dyan sa notes natin, pero lagay na rin natin yung mga atomic weights. Again, this is usually given, pero dito lagay lang natin. Hindi ko kasi sure kung nailagay ko sa notes natin. Pero dito, kailangan natin si sodium, which has an atomic weight of 23. Si sulfur, I think nabanggit na natin kanina, 32. Oxygen, nabanggit na natin kanina, ang atomic weight ay 16. And yung hydrogen, I think nabanggit din natin kanina, 1. Yung kanyang atomic weight. Okay, so again, yung mga atomic weights na yan given, hindi ko lang sure kung nailagay ko dyan sa notes natin. Pero for your reference, okay, tinype na rin natin sa chat box na yung mga atomic weights. However, atomic weights pa lang yan. Gagamitin pa natin yan to calculate the molecular weights. Okay? Pero laging tatandaan, para hindi kayo mahirapan, always start with anhydrous. Always start with anhydrous. It will make things a whole lot easier. Okay, so para daw madali, always start with getting the molecular weight of your anhydrous. So mamaya papakita ko kung bakit, no? Pero dito, compute muna natin molecular weight ng sodium sulfate na anhydrous. So, how are we supposed to solve the anhydrous natin, molecular weight? Okay, so iwan muna natin to. Kuha muna ako ng bakante slide at doon natin ilagay yung molecular weight computation natin. Okay, so try natin. Molecular weight ng sodium sulfate na anhydrous. Pag sinabing sodium sulfate anhydrous, Na2SO4 lang. Anhydrous, wala siyang lamang tubig. So that would just be Na2SO4. So anong laman ni sodium sulfate anhydrous natin? Meron siyang lamang sodium, meron siyang lamang sulfur, at meron siyang lamang oxygen. Again, ingat sa pagbibilang ng number ng atoms. Ilang pirasong sodium meron si sodium sulfate? Meron siyang 2 pirasong sodium. Meron siyang 1 pirasong sulfur. Walang subscript yung sulfur natin. So kapag walang subscript, that's automatically equivalent to 1. And then yung oxygen natin ay 4 pieces. Okay? So yung number ng atoms, number ng mga atoms natin, multiply lang daw natin with their corresponding atomic weights. And again, nilagay na natin sa chat box yung atomic weights. Atomic weight ng sodium ay 23, sulfur is 32, and yung ating oxygen ay 16. And then, multiply lang natin yung number ng atoms with their corresponding atomic weights. 2 times 23 would give us 46. 1 times 32 would give us 32. And 4 times 16 would give us 64. I-total mo lang para makuha natin yung molecular weight ng sodium sulfate na anhydrous. So 46 plus 32 plus 64, this would I think give us 142. So therefore, ano pala yung molecular weight ng sodium sulfate natin? Sodium sulfate na anhydrous will have a molecular weight of 142. Okay, so saan natin ilalagay si 142? Where are we supposed to put the 142? Kung babalikan natin yung working equation natin kanina, we will be putting 142 sa anhydrous, molecular weight ng anhydrous, denominator.
denominator ng right side of the equation. So, lagay muna natin ha. Okay, babalikan natin to ulit. Pero lagay muna natin yung molecular weight. Molecular weight ng ating anhydrous. So, 140. Okay? And then, ano susunod natin gagawin? Okay, next natin gagawin, after getting the molecular weight of anhydrous, we will now be computing for the molecular weight ng hydrated. Okay? So, dito, molecular weight tayo ng hydrated. So, try natin computein yung molecular weight ng hydrated na salt natin. So, ano nga ulit yung hydrated natin? Sodium sulfate, Na2SO4, decahydrate, meaning may 10 pirasong tubig. 10 water molecules. However, kung titingnan nyo, di ba nakuha na natin si sodium sulfate? We already got the molecular weight of your sodium sulfate that was equivalent to 142. Therefore, ang kukumputin na lang natin, idadagdag na lang natin to, yung 10 pirasong tubig, i-add na lang natin yung 10 water molecules. Ito yung reason kung bakit sabi ko sa inyo kanina, kailangan mag-umpisa kayo sa anhydrous. Always start with anhydrous para ang idadagdag mo na lang, ang kukumputin mo na lang is yung additional. Ito, sodium sulfate din naman to. Meron lang 10 tubig. So, since na-compute naman na natin si sodium sulfate kanina, ang i-add mo na lang ngayon is yung 10 water molecules. So, therefore, kukumputin nga rin ngayon yung molecular weight ng water molecule natin. Remember, ang water natin ay H2O. So, dito, H2O, meron siyang 2 pirasong hydrogen, at meron siyang 1 pirasong oxygen. Kaso ang problema, ilang pirasong hydrogen, ilang pirasong oxygen meron sa 10 pirasong tubig. Meron ka daw 10 water molecules kada water molecule may 2 hydrogen. So that means 2 times 10. So 2 times 10 we have 20. Okay, you have 20 pieces of the hydrogen atoms natin. Okay, again ha, 10 piraso kasi yung tubig kada tubig may 2 pirasong water. So, 2 times 10 would give us 20. Okay? Tapos, ilang pirasong oxygen meron? Kada water molecule may 1 pirasong oxygen, meron kang 10 tubig. Meron kang 10 water molecules. So, 10 times 1, that would give us 10. Okay, so again, ingat sa pagbibilang ng number ng atoms ha. Okay, dito yung subscript, minultiply natin dun sa number of the molecules natin. So, 2 times 10 would give us 20. 1 times 10 would give us 10. So, we have 20 pieces of hydrogen all in all, 10 pieces ng oxygen all in all. And syempre, kagaya kanina, multiply lang natin sila with their corresponding atomic weights. And again, binigay na natin yung atomic weight kanina. Atomic weight ng hydrogen is 1. Atomic weight ng oxygen natin ay 6. Multiply lang natin yung number ng atoms with their corresponding atomic weight. So that means we have 20 times 1 would give us 20, and 10 times 16 would give us 120, or 160 rather. 160, to total lang natin, 20 plus 160, that would give us 180. So therefore, ano yung molecular weight ng 10 tubig or 10 water molecule natin? That would give us 180. Anong gagawin natin sa 180? I-add lang natin siya dun sa sodium sulfate natin. Kanina, ang sodium sulfate natin ay 142. I-add lang natin yung 10 water molecules. So we have 142 times 180. That would give us 320. So, okay, so 322. Now we have 142 plus 180. So yes, we have 322. Ito ngayon yung magiging molecular weight ng hydrated na salt natin. Kanina yung 142, anhydrous pa lang yon. Pero this time, we have the sodium sulfate decahydrate, 322. So, where are we supposed to put the 322? Ilalagay mo naman siya ngayon sa numerator. Numerator ng right side ng ating equation. Okay, so numerator sa right side ng ating equation. So, dito na natin isulat now. We have x over 8 is equal to 322 over 140. So, ito yung molecular weight ng ating hydrated over the molecular weight of the anhydrous. So, ito na ngayon yung working equation natin. So, working equation, we have x over 8 is equal to 322 divided by 142. Uy, may fraction sa left, may fraction sa right side. What's the most mathematical thing to do in here? Crisscross. Cross multiplication. So that means we have x times 142. Remember, any number, any figure multiplied by x would give us x in here. Plus, ilalagay natin si 142 sa unahan kasi multiply natin siya. Mamultiply natin siya. We have 142 times x. Kasi itong x sa unahan, may automatic na 1 yan sa unahan eh. Itong x, kapag wala siyang number sa unahan, automatic may 1 yan sa unahan. So, 1 times 142 would give us 142 with the x, kaya siya naging 142 x in here. Okay? And then, yung kabilang side naman, we have what? Okay, we have 8 times 322. Okay, so 8 times 322 on the right side of the equation, or you can also say it's 322 multiplied by 8. Okay, so 8 multiplied by 322 on the right side of the equation. And what is 8 multiplied by 322? That would give us 2576. So, lagay natin in here. So, we have in here 142 times x is equal to 322 times 8. That would give us 2,576. Okay, so anong gagawin natin? Again, yung rule natin sa math, hindi pwedeng may kasama si x. So, anong gagawin natin? Kailangan natin tanggalin si 142. How do we again get rid of 142? Di-divide mo lang siya sa sarili niya. I-divide natin sa 142. Pag may 142 sa taas, may 142 sa baba, maka-cancel out, may iiwang mag-isa yung ating x. However, whatever you did on the left side, you have to do the same exact thing on the right side. Kung dinivide mo yung left side by 142, yung right side, i-divide mo rin by 142. And what is 2576 divided by 142? This would give us 18.14. Okay, 18.14 grams. Okay, so ilan daw grams ng sodium sulfate na decahydrate ang gagamitin natin? So to answer the question natin, we would be needing 18.14 grams. Okay, so 18.14 grams ng sodium sulfate na decahydrate. So therefore, for item number 14, the answer is 18.4. Okay? Etong problem na 'to, nagmukha lang naman siyang complicated kasi nag-compute pa tayo ng molecular weight. Actually, yun talaga yung nagpa-toxic dun, eh. Ang nagpa-toxic sa problem na 'to is we had to compute pa kasi the molecular weight. Pero may mga ganitong problem sa board exam na given na, eh. Given na si molecular weight. So, you really don't have to do any of this anymore. Eto na lang yung gagamitin ninyo. Okay, yung ratio and proportion na lang ang gagamitin natin. Kasi 'pag board exam, minsan binibigay. Minsan nga lang hindi pa binibigay. Kaya 'pag di pa binigay, wala kayong choice but to compute pa first the molecular. Okay, pero kung tutuusin, simpleng ratio and proportion lang naman 'to dapat na problem, eh. Okay, ang nagpa-complicate lang is the calculation of the molecular weight. Okay, pero still, congratulations, we have arrived on the final answer. The final answer is 18.14. And alam niyo ba, itong problem na 'to was actually an exact question dati no board exam that was actually copied from the book of Kaplan. This is in fact a sample problem dun sa clinical chemistry book ni Kaplan na ginamit ng mga board of examiner as a question dati sa board exam. And another weird thing is itong question na to ay paulit-ulit nang nag-appear ng board exam. As in, same na same yung given, same na same, ultimo tuldok, same na same. So therefore, pag nakita nyo, uy, same na same yung problem, no? Tandaan nyo na lang yung final answer. Okay, para hindi na kayo mahirapan. 18.14. Okay, so yun na lang, no? Pag nakita nyo, uy, kapares na pareha, sodium sulfate, decahydrate, ang given, same na same. Okay, hanapin nyo na lang yung final answer. 18.14. Okay, para di na daw mahirapang mag-compute. Okay, pero either way, final answer natin for this one is 18.14. Okay? So, yan isa sa mga complicated problems sa board exam, no? Na hindi mo talaga papangaraping ma-encounter kasi ubos ang oras mo sa computation. Okay, computation pa lang, ubos na ang oras. Okay, pero that's for item number 14. Okay, let's try to move to the next item natin. So, we have item number 15. Okay, so puntahan natin si item number 15. Okay, item number 15. Okay, we have this question. Okay, so this is this time a dilution related na problem. Okay, dilution related na problem. Ito medyo universal na question din to, no? Minsan nasa AUBF to eh. Minsan naman nasa histotech, minsan naman nasa clinical chemistry. Okay, so let's try to read on the problem muna.
What is the dilution daw if 5 ml of sample is mixed with 15 ml of the diluent? Okay, so how are we supposed to solve for the dilution? Ingat kayo ha, dilution is equivalent to the volume of the sample. Volume of the sample divided by the total. Total volume. Now, please be careful ha. Ang nasa denominator ay total volume. Ano ba ibig sabihin pag sinabi total volume? Pag sinabing total volume, volume ng lahat. Lahat. So, pag sinabing lahat-lahat, hindi lang diluent ang ilalagay nyo sa denominator ha. Please don't forget to add the volume of the sample. Ito yung most common mistake hindi lang ng mga students, pati ng mga medtechs. Okay, mga medtechs, no, minsan nagkakaroon pa ng problema sa ganito. Minsan kasi ang ginagawa nila, sample over the diluent lang. Ingat kayo, pag sample over the diluent lang, hindi yan dilution. Ratio pa lang yan kapag sample over the diluent. So mag-iingat kayo ha. To make it dilution, dapat yung diluent, dadagdagan mo ng volume na sample. Okay? Kasi pag ang ginawa mo siya, sample lang over the diluent plus the diluent lang, ratio lang ang magagawa natin. Kailangan ng nasa denominator ay palaging total volume. Okay? So therefore, it should be diluent plus the sample. Okay? Substitute natin yung given on the equation. Ilan daw yung volume ng sample natin? Ang sample volume natin ay 5. I-divide daw natin with the volume of the diluent. Ang diluent daw natin ay 15 ml. Buo na ba ang equation? Hindi pa. Don't forget to add again the volume of the sample. And ano ulit yung volume ng sample natin? 5 ml. Okay, so that gives us 5 over 15 plus 5 would give us 20. And what is 5 over 20? 5 over 20 is equivalent to 1 over 4, or in short, 1 is to 4. Okay, so 1 is to 4. Ito ngayon yung magiging final answer natin. Oy, teka ma'am, paano naging 1 over 4 yung 5 over 20, ma'am? Paano naging 1 over 4 si 5 over 20? Kung naalala nyo pa sa math to, ang tawag yata dito ay simplifying fraction. Simplest term. Simplest terms. How do we get the simplest terms of 5 over 20? Okay, ganito. Yung numerator, divide nyo lang sa sarili niya. So 5, divide natin by 5. 5 divided by 5 would give us 1. However, life has to be fair. Kung ano yung ginawa mo sa taas, ganun din sa baba. Kung dinivide mo yung numerator by 5, dapat yung denominator din, i-divide mo rin by 5. So 20 divided by 5. And what is 20 divided by 5? That would give us 4. So that's why we ended up with 1 over 4, or in short, 1 is to 4. Okay, so therefore, ano daw pala yung dilution na nai-prepare ni MedTech in here? The MedTech na managed to prepare a 1 is to 4 na dilution. Okay, so therefore, to answer your item number 15 is a dilution-related problem. The final answer is 1 is to 4. Okay, so 1 is to 4 for item number 15. Marami pa tayong mga sample, marami pa tayong mga dilution-related problems, no? Pero probably pag-uusapan na lang natin sa ISBB. Okay, kasi parang ako rin yata yung mga kasama nyo sa immunosero blood banking. Okay, pero marami pa tayong iba pang samot-saring dilution problems, no? Pero pag-uusapan na lang natin siya when we get there. Okay, pero for the meantime, this is the simplest possible dilution problem, no, that you may get to encounter sa board exam. And final answer for this one is 1 is to 4. Okay, so ingat lang ha, iba ang ratio sa dilution. Okay, so for item number 15, we have 1 is to 4 as the final answer. Okay, so let's try to look at the next item natin. Following item number 15, we now have item number 16. And item number 16 is an anion gap related naman na problem. Okay, let's try to look at this one. Item number 16. Okay, item number 16, an ion gap. We have this one. Determine daw the anion gap natin. Okay, we were given the sodium, the chloride, the potassium, and the bicarbonate. So we are asked about the anion gap. And ano nga bang formula ng anion gap natin? Anion gap, alam niyo ba ng board exam? Hindi ko sure kung naikwento ko na to last time. Pero ng time ko ng board exam, we were just simply asked about the formula of the anion gap. As simple as that. Pinapapili lang sa amin, no, sa choices, sino yung correct formula ni anion gap. However, nung tinignan namin yung choices, walang tamang sagot. Walang tama sagot. Ingat kasi may mga times talaga na nasa board exam ay walang tamang sagot. Yung tipong kahit baliktarin mo yung paper mo, wala kang makikitang tamang sagot. Okay? Kaya mag-iingat kayo. Hindi naman 100% perfect ang board exam eh. May mga items na walang sagot. In fact, may mga items nga na dalawa eh, yung tamang sagot. Okay? May mga times no, na dalawa ang tamang sagot. Okay? So therefore, you really have to be careful. Okay, you just have to choose what you think is the closest possible answer. Okay, pero either way, substitute natin yung given on the equation. Sodium plus potassium minus chloride plus bicarbonate. That is how we get the anion gap. By the way, another important thing. Sino pala yung pwede na nating tanggalin sa anion gap computation? Recall question to ha. Kasi itong factor or parameter naman daw na to, least likely to affect the anion gap. Kumbaga wala siyang bilang, pwede mo na siyang tanggalin, i-echepuera sa computation of the anion gap. Recall question, least likely to affect the anion gap will be your potassium. After all, ang potassium natin, di ba, is the major intracellular cation. Medyo konti lang siya sa serum, konti lang siya sa plasma. So, konti lang yung effect niya sa ating anion. Kaya naman yung ibang libro, minsan kapag walang binigay na potassium, hindi na ginagamit si potassium. Minsan, ang ginagamit na lang nila, diretso na, sodium minus chloride plus bicarbonate. Tinatanggal na nila si potassium sa computation. Pero by the way ha, kapag binigay si potassium, gamitin si potassium. Gagamitin niya lang tong second formula natin if the potassium was not given. Pero kung given naman, gamitin nyo naman si potassium. Sayang naman yung effort ng pagsulpot ni potassium kung hindi nyo siya gagamitin. So if the potassium naman is given, make use of the potassium. And in this case naman, the potassium is given. Well, let's make use of the potassium. So we have sodium plus potassium. That means we got 140 for the sodium plus your potassium, which is 5, minus the chloride, which is 87, plus 35, plus 35 for your bicarbonate. Okay, so dito, let's try to add them muna. 140 plus 5 would give us 145, minus 87 plus 35. 87 plus 35 would give us 122. And what is 145 minus 122? That would give us 23. Therefore, the anion gap is equivalent to 23. Okay, so again ha, recall question. Sometimes they would just ask you for the formula of the anion gap. Okay, pangalawa, tinanong na rin dati ng board exam ha, kung sino yung pinaka or hindi rather nakaka-apekto sa anion gap, kaya pwede mo nang tanggalin sa computation. We can already remove the potassium from the computation kasi potassium is least likely to affect the anion gap. And pangatlo, wag kakalimutan ha, pangatlong bagay pagdating sa anion gap. The members of the anion gap are actually the members of the electrolyte panel natin, which happens to be a recall question. Recall question, sino-sino daw yung mga miyembro ng electrolyte panel? They would give you choices, 4 na electrolytes kada choices, and they would ask you sino yung tamang combination ng mga members ng electrolyte panel. Ingat kayo ha, sodium, potassium at saka chloride. Yung pang-4 ay hindi calcium ha. Ingat kayo, taken from the book of Bishop, ang pang-4 na miyembro pala ng electrolyte panel ay si bicarbonate. The members of the anion gap, sila pala yung mga miyembro ng tinatawag nating electrolyte panel. So ingat kayo ha, minsan kasi akala ng mga students si calcium yung pang-4 na member, pero in fact the answer is no. Bicarbonate pala yung pang-4 na member ng electrolyte panel. You can find that in the book of Bishop and recall question, no? Yung mga miyembro ng electrolyte panel. Okay, so still don't forget how to compute the anion gap. In this case, item number 16, the final answer will be equivalent to 20. Okay, so 23 would be the anion gap. Okay, so I hope clear naman itong item number 16 natin. Okay, so again ha, formula ng anion gap form ay recall question. Least likely to affect the anion gap is also a recall question. And syempre, recall question din si potassium being the major intracellular cation. And syempre, don't forget the members of the electrolyte panel. Sodium, potassium, chloride, and bicarbonate. Okay, so item number 16, the final answer will be 23. Okay? What about the next question natin? Next question, we have item number 17. Okay, let's try to look at item number 17. Si item number 17 nga pala ay minsan sa CleanChem tinatanong pero minsan nasa AUBF to tinatanong si creatinine clearance. Okay, item number 17, we're asked to compute for the creatinine clearance given the following values. We have the urine creatinine which is 60, plasma creatinine which is 1.73, and then we have the body surface area which is 1.2, and the urine volume which is 2,880 ml per 24 hours. And we are asked about the creatinine clearance. Okay, now, creatinine clearance has a lot of recall questions, ha? Ano na ba yung mga recall questions patungkol sa creatinine clearance? Una, purpose. What is the ultimate purpose of your creatinine clearance? Okay, para saan ba ginagamit si creatinine clearance? Ginagamit to as a kidney function test, di ba? Kidney function test. Kaso ingat kayo, anong specific function ng kidney ang ina-assess ng creatinine clearance? Anong specific function daw ng kidneys ang ina-assess ng creatinine clearance natin? Recall question. Creatinine clearance is used to assess glomerular filtration. Meaning to say, gusto niya or ginagamit natin si creatinine clearance pag gusto mong malaman kung nag-filter ba talaga si glomerulus. Gusto mong malaman kung nag-filter ba talaga. Nag-filter ba talaga si glomerulus? After all, si glomerulus is the filtering apparatus, di ba? It's the filtering apparatus of the nephrons or the nephrons natin. Okay, therefore, paano malaman kung nagtatrabaho ba yung glomerulus mo? Baka mamaya may glomerulus ka, display lang pala yung glomerulus mo. So, how would you know if your glomerulus is really doing the filtration na process? We can make use of the creatinine clearance. Okay, and ma'am, how do we compute for the creatinine clearance? Okay, formula. Recall question number 2, formula ng creatinine clearance. Okay, ilatag muna natin yung formula bago natin pag-usapan ng mga detalye. Creatinine clearance. How do we get the creatinine clearance natin? Okay, creatinine clearance, ingat kayo sa formula. Okay, this is equivalent to, sa numerator, ilalagay natin ang urine creatinine. Okay, so urine creatinine, i-multiply mo lang with the volume. The volume of 24-hour na urine. 24-hour na urine, and by the way, make sure na naka-express na siya ha in ml per minute. Bago mo siya isalpak sa equation, make sure that the volume of the urine, the 24-hour urine, dapat naka-ml per minute na siya. Kaso pagdating sa board exam, kadalasan yung ating urine volume, naka-ml per 24 hours pa siya. So make sure to convert it ha, bago niyo siya ilagay dun sa ating equation. Okay, dun sa ating formula, make sure na convert natin si ml per 24 hours into ml per minute. Bakit nga pala kailangan naka-ml per minute? Bakit kailangan naka-ml per minute yung volume ng urine natin? Kasi ang unit kasi ng creatinine clearance ay ml per minute. So that's why dapat dito pa lang para makuha natin yung lalabas na ml per minute, dapat volume pa lang ng urine naka ml per minute na. Okay? I-divide lang daw natin yon with the plasma or pwede rin namang serum. Plasma or serum creatinine. Okay, plasma or serum creatinine. Kaso hindi pa tapos ha. Don't forget na i-multiply pa natin yan with 1.73. By the way, 1.73 is a constant. 1.73 divided by the body surface area or what we call the BSA. Okay, BSA, body surface area. Okay, so ito yung formula ng ating creatinine clearance. Now, important notes about the creatinine clearance computation. Okay, ano yung mga importanteng bagay na dapat tandaan sa creatinine clearance natin? Number 1, don't forget na si creatinine clearance, again, as mentioned kanina, ginagamit yan to assess. They are intended to assess glomerular filtration. Okay, ginagamit yan para malaman kung nag-filter ba talaga si glomerulus or hindi. Okay? Pangalawang bagay na dapat tandaan sa creatinine clearance computation, laging tatandaan yung
volume. Okay, volume ng 24-hour na urine. Okay, the volume of the 24-hour urine. Question nga pala, bakit kailangan 24-hour urine? The urine specimen daw pala should be a 24-hour na urine. Okay, ang tanong is bakit kailangan 24-hour urine? Ang hassle naman, no? Hindi ba pwedeng random urine na lang? O kaya, ma'am, first morning urine na lang. Bakit hindi ganun? Bakit kailangan 24-hour na urine? Does it really have to be 24-hour na urine? Ang tanong is bakit? Bakit 24-hour na urine? Okay, ganito yan ha. It actually has something to do with the identity of your creatinine. Ano ba kasi si creatinine? Creatinine, kung naaalala nyo pa sa clinical chemistry din naman, pero creatinine is the end product or like it's the waste product, di ba? It's the waste product or end product of muscle metabolism. End product or waste product siya ng muscle Okay, ma'am. Ano naman ngayon kung end product siya, ma'am, ng muscle metabolism? Ibig sabihin, every time you move your muscle, nakakapag-produce yan ng creatinine. Ang tanong, pare-parehas ba yung movement ng muscle natin sa loob ng 24 oras? Sa loob ng 24 oras, consistent ba yung paggamit natin ng muscle? Consistent ba yung paglabas ng creatinine natin? The answer is no. The answer is no. Iba ang workload natin during the day compared sa workload natin sa gabi. Mas marami tayong kinikilos usually during the day at saka mas less yung kinikilos natin usually sa gabi. In short, iba-iba yung gamit ng muscle mo all throughout the 24-hour period. Iba-iba yung labas ng creatinine natin. So imagine, what if one random urine ang ginamit mo? Tapos kakatapos lang mag-exercise ng pasyente mo. Kakatapos na lang mag-exercise, edi tataas ang creatinine. Okay? What if first morning ang urine? Tapos galing sa pagkakahiga yung pasyente mo. Galing sa higa, walang masyadong muscle movement. Pagkabangon, first morning urine, anong mangyayari? Wala siyang masyadong muscle activity. Lesser yung urine. Lesser yung creatinine na lalabas sa kanya. So, hindi advisable yung random, hindi advisable yung 24-hour urine, no? Kasi iba-iba eh. Iba-iba ang labas ng creatinine natin all throughout the 24-hour na period. So, to standardize things out, para mas standardize yung creatinine output natin, mas maganda 24 oras. Okay? Para anumang oras ka mag-exercise, at least humahagip siya within the 24-hour na period. Okay? So, yun pala yung reason no, kung bakit ang urine, dapat 24-hour urine kasi creatinine is the end product of muscle metabolism. Magkakaiba ang muscle activities natin. Different ang muscle activities natin all throughout the 24-hour na period. Okay? Another important thing, okay ma'am, tanggap na namin ang katotohanan that it has to be a 24-hour na urine, which brings us to the recall question. Ano ba yung greatest source of error when it comes to any clearance procedure? Not just creatinine, ano? Any clearance na procedure. Ano daw yung greatest source of error when it comes to clearance procedure? Usually kapag clearance kasi gumagamit ng 24-hour urine. At ang greatest source of error lies on the 24-hour urine, especially pag improperly collected. Improperly collected ang 24-hour na urine. Okay, recall question ha? Greatest source of error in any clearance procedure, including the creatinine clearance, lies on the improperly collected na 24-hour na urine. Okay, ma'am, paano ba kasi mag-collect ng tama? How do we properly collect the 24-hour na urine? Try natin. How do we collect the 24-hour na urine? So for example, day number 1, start ka today, kunwari, first day. Okay, we have first day. Meron kang first morning urine. Okay, nag-start ka ng 7 a.m. Meron kang first morning urine of the first day. Should we include the first morning urine of the first day natin? Are we supposed to include the first morning urine of the first day? The answer is no. Hindi natin yan isasama. Bakit? Bakit hindi natin isasama yung first morning urine of the first day? Why? Kasi remember, ang first morning urine natin represents the urine na naipon sa katawan mo nung ikaw ay natutulog. It represents the urine that accumulated inside your body while you are sleeping. Ano bang average na number of hours ng tulog? ng isang normal na individual? How many hours ba normally ang tulog ng isang normal na individual? With emphasis, normal na individual. Okay, a normal individual, no, ang sleeping time should be around 6 to 8 hours. So, ang tanong, normal pa ba kayo? Okay, 6 to 8 hours daw, no? Ang average na tulog ng isang normal na person. Okay, normal na person with emphasis. However, in this case, what if isinama natin yung first morning urine of the first day? Eh di hala, sasama yung urine na naipon sa'yo nung ikaw ay tulog. Eh kasama na ba yun sa 24 hours? Hindi pa. Laging tatandaan, you have to start with an empty bladder. Dapat walang laman ang bladder mo bago ka mag-start. So, hindi natin pwedeng isama yung first morning urine of the first day. Kasi ang mangyayari, pag sinama mo yan, yung 24 hours mo, madadagdagan ng 6 to 8 hours. Ano mangyayari? Yung 24 hour mo, magiging 32-hour na urine na kapag isinama mo yung first morning urine. So, that's why the rule of thumb ha, you have to start with an empty bladder. Dapat i-discard ang first morning urine of the first day. But after doing that, you will have to collect everything. After discarding the first morning urine of the first day, you will have to collect everything until the next day. 24-hour na urine, so until 7 a.m. of the next day. Uy, 7 a.m. of the next day, may first morning urine ka na naman. May first morning urine ka na naman, pero this time of the second day, are we supposed to include that? I-include ba natin ang first morning urine of the second day natin? The answer is yes. Yes, you will have to include that. Bakit? Kasi itong first morning urine of the second day represents the urine nung ikaw ay natutulog. Kasama pa ba yon sa 24 hours natin? Yes, kasama pa yon sa 24 hours natin. So therefore ha, yan yung importanteng rule. You should never include the first morning urine of the first day, but you have to include the first morning urine of the second day. Okay, para masabi natin na 24-hour yung urine na nakolek. Okay, so therefore, yan ang tamang paraan ha ng pagko-collect ng 24-hour urine. At mahirap tong gawin, especially kung outpatient si pasyente. Kung bedridden or inpatient naman kasi yung patient mo, si nurse na ang bahalang mag-monitor ng 24-hour urine collection di pasyente. Ang problema kapag outpatient si pasyente, di naman monitor. Minsan may mga pasyente ang sipag mag-collect, isinasama pati first morning urine of the first day. Okay, not following instruction si pasyente. Minsan naman may mga pasyenteng makakalimutin. Ihing-ihi na, nagpunta na ng CR, kalahati ng urine na deposit na sa toilet bowl, tapos naalala na, uy, magko-collect pala ako 24-hour urine. Pinigilan ang pag-ihi. The remaining urine was placed on the bottle. Would that still be accurate? Magiging accurate pa ba yon? Hindi na. Every drop counts, ha? Laging tatandaan, every drop counts daw, sabi nga ng Shell. Make sure na kumpleto yung 24-hour urine collection. Okay, so therefore, wag kakalimutan recall question. The greatest source of error in any clearance procedure such as the creatinine clearance will be on the improperly collected na 24-hour na urine. Okay, so that means dapat tama ang pagko-collect ng 24-hour urine. Okay? Another important thing to remember, yung 24-hour urine natin. The 24-hour urine should be expressed in what? The 24-hour urine should be again expressed in ml per minute. Again, why do we have to express it in ml per minute? Kasi creatinine clearance is expressed kasi in ml per minute. Okay, so kailangan yung 24-hour urine mo dapat naka-express na in ml per minute kasi ang ending na unit ng creatinine clearance natin is also ml per minute. Okay? Kaso, ang given sa atin kadalasan, ml per day, ml per 24 hours. Kaya kailangan i-convert. 1 day is equivalent to 24 hours and 24 hours, i-convert lang natin siya into minute. Okay, so 1 hour is equivalent to 60 minutes. Okay, so yun yung mga conversion na gagamitin natin, especially kung ml per day pa. Ko-convert mo siya into ml per minute. Okay? So with that, yan yung pang-apat na dapat tandaan ha when it comes to creatinine clearance. 24-hour urine should be expressed in ml per minute. Now, the last important thing to note of, etong nasa dulo. Recall question. Para saan si 1.73 over the body surface area? What is the purpose of putting that 1.73 over the body surface area sa dulo ng equation natin. Okay, recall question, ano nga bang purpose niyan? This is intended to correct for the muscle mass of your patient. Okay, para saan daw pala si 1.73 over the body surface area? Ginagamit daw pala yan to correct. Pag sinabing correct, adjust. Para daw makapag-adjust tayo dun sa muscle mass ng ating patient. Teka ma'am, why do we have to do that? Bakit kailangan namin mag-adjust ma'am? Mag-adjust for the muscle mass of your patient. Kasi again, this brings us back to the definition ng creatinine. Ano nga ba yung definition ng creatinine natin? Is the end product of muscle metabolism. It is the end product of muscle metabolism, meaning the more muscles you have, the more chances of winning. Okay, the more muscles you have, the more creatinine there would be. Kasi production ng muscle metabolism. Pag mas marami kang muscle, hindi mas maraming creatinine na lalabas. So therefore, para saan si 1.73 over the body surface area? Ginagamit yan to standardize, to correct for the muscle mass of your patient. Kasi syempre, iba-ibang tao, iba-iba naman ang amount ng muscles, ano? So, para matanggal yung factor na yon, para hindi makaapekto yung muscle mass ni pasyente, dito kailangan natin gamitin si 1.73 over the body surface area. Ang goal lang nito is to make things comparable para maging comparable yung mga result. Okay, let's try to give some hypothetical example. For example, nagpa-crea clearance sa'yo, sina Batista, o kaya sina The Rock. Okay, maraming muscle. O kaya kung medyo classic kayo si Arnold Schwarzenegger, ganyan. Siyempre marami silang muscle. How can you make their results comparable to someone who doesn't even have much muscles? Anong gagawin mo para maging comparable ang result ng isang taong maraming muscles compare sa isang taong walang masyadong muscles? So para maging comparable, you need to correct or to adjust for the amount of muscles that they may have. Okay, kasi siyempre 'pag mas maraming muscle, mas maraming creatinine, makakaapekto 'yun sa magiging result natin. Okay, so that's why we have to use the 1.73 over the body surface area thing. And ma'am, let's add a twist to the story. Ma'am, what if walang binigay? What if walang binigay, ma'am, na body surface area? Walang binigay, walang gawin niyo lang, tanggalin niyo lang 'tong last part nung ating formula. Okay, tatanggalin niyo lang yung last part ng formula. Tatanggalin niyo lang yung 1.73 over the body surface area. You just have to remove that part, yung 1.73, o mali yung na-box ko. Okay, 1.73 over the body surface area. Okay, tatanggalin niyo lang siya. Okay, yung part na yon. Okay. Pasensya na, medyo miss ang aking mark kasi naka-open yung chat box eh. Sorry. Ay, medyo miss yung aking pagkaka-box. Okay, tatanggalin niyo lang tong 1.73 over the body surface area, no? Okay? Para ang gagamitin niyo lang is ito, kasi kapag walang binigay na body surface area, it means na average siya. Average yung kanyang body surface area. So you will just have to use this part of the equation. Ito na lang ang gagamitin natin. Ano? Okay? Kapag sakali lang naman. Pero don't worry, pag exam, binibigay si body surface area eh. Kaya mas maganda kung kabisado niyo yung buo. Mas maganda kung kabisado niyo yung buong formula. Kasi most of the time, binibigay si body surface area. So for that, you will have to make use of it. So mas maganda kung kabisado niyo yung buo. Yung buong formula ng creatinine clearance natin. Okay? So those 5 items no are the 5 important matters that you need to take note of when it comes to the creatinine clearance na computation. Kasi minsan tinatanong yan sa ClinChem, minsan sa AUBF siya tinatanong. Okay? But then again, let's go back to the main problem natin. Substitute natin yung given dun sa equation natin. Okay? So burahin ko lang etong lower part. Okay, let me erase this portion first. Okay, tas gamitin natin yung formula no, to calculate for the creatinine clearance natin. Okay, dun sa given natin, ano na nga yung urine creatinine ng ating pasyente? Teka, let me erase this one first. Okay, and let us try to substitute muna the given on the equation natin. Okay, so ano ba yung value ng urine creatinine natin? So ano ba yung binigay sa urine creatinine natin? Teka, let me go back to the notes natin. Ang urine creatinine natin ay 60. Okay, so let's put in here 60. 60 milligrams per deciliter. At ang binigay na plasma creatinine, lagay muna natin yung plasma creatinine sa denominator, 1.73. Tapos, 1.73 in here, over the body surface area, binigay yung body surface area, the body surface area was 1.20. 1.20. Kaso meron tayong problema, yung volume ng 24-hour na urine. Okay, volume ng 24-hour urine kasi, ang binigay sa atin ay 2,880 ml per 24 hours. But remember, ang kailangan natin is ml per minute. So we will have to do the conversion first. Ko-convert natin si hour into minutes. And syempre, ang conversion factor natin, 1 hour is equivalent to 60 minutes. Okay, so anong gagawin natin? Multiply lang natin to dun sa conversion factor natin. And ingat, sino ilalagay natin sa numerator? Sino ilalagay natin sa numerator? Si 1 hour or si 60 minutes? In this case, ang ilalagay natin sa numerator ay si 1 hour, si 60 minutes ha, ang ilalagay sa denominator. Ingat kayo, bakit na nga nilagay si 1 hour sa numerator? Kasi gusto natin ma-cancel out yung hours. Gusto natin matanggal yung hour sa denominator. Gusto natin maging minute. And remember, pag may gusto kang tanggalin, saan mo ilalagay yung kamukha niya? Sa opposite side. Since nasa denominator itong hour na gusto nating tanggalin, yung kamukha niya, lalagay mo sa numerator para ma-cancel. Pag merong R sa taas, may R sa ibaba, they would get canceled out. Ano na lang may iwan? ml per minute. Okay, so therefore, yan yung magiging working equation natin here. So we have 2,880 ml times 1. That would give us 2,880 ml on the numerator. 24 times 60, that would give us 1,440 minutes on the denominator. And what is 2,880 divided by 1,440? That would give us 2 ml per minute. So, siya ngayon yung ilalagay natin dito sa volume. Volume pa lang yan ha, hindi pa yan yung final answer. Kinonvert pa lang natin yung ml per 24 hours into ml per minute. So, dito ilalagay natin 2 dito sa volume ng 24-hour. Okay? So, ito na ngayon yung magiging working equation natin. Para let us make things easier. Remember, pag may magkamukha sa taas at sa baba, they would get canceled out. So since may 1.73 sa taas, may 1.73 sa baba, maka-cancel out yan. Ang may iwan ay 60 times 2. And what is 60 times 2? Okay, diretso na natin compute. 60 times 2, that would give us 120. And divide lang natin with 1.2. And what is 120 divided by 1.2? Para madali, kung tinatamad kayo maglabas ng calculator, gawin natin tong whole number. Move natin siya ng 1 decimal place to the right side. Para si 1.2 ay maging 12. But remember, life has to be fair. Whatever you did below, you have to do the same exact thing above. 120, nandito yung decimal point. Move mo din yung decimal point, 1 decimal place to the right side. Add ka ng 0 para magandang tingnan, si 120 ay magiging 1,200. Okay? Pag may magkamukha sa taas, magkamukha sa baba, they would get canceled out. Ang may iwan will be dalawang 0. Lagyan mo ng 1 sa unahan para magandang tingnan. You would end up with 100. 100 ml per minute. Okay, so therefore, ano palang final answer natin in here? We have 100 ml per minute as the glomerular filtration rate or yung creatinine clearance value rather no, ng ating patient. Okay? Ginawa ko lang siyang ganyan ha kasi tinamad ako maglabas ng calculator pero chinek ko na rin siya sa calculator. 120 divided by 1.2 no would give you 100. Okay, so therefore, final answer is 100 ml per. Okay, so 100 ml per minute, the creatinine clearance result of your patient. Okay? So, convert muna natin yung urine volume into ml per minute bago natin siya sinalpak dito. And after computation, your final answer will be equivalent to 100. Okay? So that is how we compute the creatinine clearance. And again, don't forget yung mga important notes na nabanggit natin kanina ha, about the creatinine clearance na computation. Okay? Kasi yung mga questions na yan, minsan sa ClinChem, minsan sa AUBF sila tinatanong. Okay, so at least try to be familiar with. Okay, so that's it for item number 17, the problem that concerns the creatinine clearance computation natin. Okay, what about the next item natin? Next question natin, item number 18. So what's on item number 18 natin? We have, or we are asked to determine the LDL cholesterol level. Okay, so how do we get the LDL cholesterol natin? So meron tayong given. We have the total cholesterol. We also have your triglyceride or TAG. And then we also have the HDL cholesterol. Okay, so we will be using in here the Friedewald or the Friedewald equation. So Friedewald equation states that your LDL in milligrams per deciliter is equivalent to the total cholesterol minus the HDL minus triglyceride divided by. Okay? So this is how we would compute the LDL. So try natin i-substitute yung given on the equation. Given on the equation, ang given sa atin ay total cholesterol of 250 minus the HDL which is 45 minus triglyceride which is 140. But first you have to divide it with 5. Okay, and what is 140? 140 divided by, sorry, 140 divided by 5, that would give us 28. Okay, so that means we have 250 minus 45 minus 28. Okay, and what is 250? 250 minus 45 minus 28. Okay, that would give us 177. So what is now the LDL cholesterol value of your patient in milligrams per deciliter? So this would be equivalent to 177. 177 milligrams per deciliter. Okay, so that would be the LDL level natin. Now be careful ha, kasi may mga instances na hindi LDL ang pinapahanap. Instead, ang pinapahanap ay si VLDL. So, mag-iingat kayo ha. Kapag LDL kasi, you will have to use the entire Friedewald equation. Pero pag ang tanong ay VLDL lang, all you have to use is the last part of the equation. Etong triglyceride divided by 5. So, mag-iingat kayo sa tanong ha. Isa lang letra ang difference ng LDL at VLDL natin, but that can change the choices that we make. So, mag-iingat kayo. Kapag LDL ang tanong, use the whole Friedewald equation. Pero kung VLDL ang tanong, you can estimate it by simply using triglyceride over 5. Triglyceride over 5 kapag VLDL, pero pag LDL, gagamitin yung buong equation. Okay? Mag-ingat ha, kasi dati nang tinanong yan si VLDL, dati nang naitanong si VLDL. Kaya you have to be extra careful. Okay? Pero that is how we solve for the LDL cholesterol using the Friedewald equation. Final answer natin for item number 18. For number 18 now, we have, what? Okay, we have 177. Hindi ko pala nilagay yung answer sa number 17. So, number 17, ang answer natin, hindi ko na i-type sa chat box. Okay, 100 ml per minute. Okay, yung kanyang magiging creatinine clearance. And for item number 18, 177 milligrams per deciliter, yung magiging LDL. Okay, so LDL cholesterol ni pasyente, 177 milligrams per deciliter. Okay, so that's it for item number 18, the problem that concerns the Friedewald or the Friedewald equation natin. Okay, however, what about the next item natin? Item number 19. Okay, let's try to look at item number 19. We are asked to determine the carbonic acid level. Okay, so we were given the pH, we were given the carbon dioxide, the bicarbonate, and even the delta content. Now we're being asked to determine the carbonic acid level. By the way, carbonic acid is your H2CO3. Now, ingat ha, kasi nako-confuse yung mga student sa bicarbonate at saka sa carbonic acid. Ang bicarbonate kasi ay HCO3, pero ang carbonic acid ay H2CO3. Okay, so mag-iingat lang ha. 2 lang kasi yung difference ng carbonic at saka ng bicarbonate natin. Okay? So, how do we get the value of your carbonic acid level? Alam nyo ba na ang daming given sa atin, pero hindi naman pala lahat yan gagamitin natin? Ma'am, sino lang ang gagamitin natin? Well, we would only be using the carbon dioxide. So, ma'am, how? Ito yan. Carbonic acid is just equivalent to your PCO2. Multiply mo lang with a factor, and that factor is 0.031. 0.031. 31. Now, that sounds and looks familiar. Saan natin nakikita itong PCO2 multiplied by 0.03 or 0.031? You can find that on the denominator of the Henderson-Hasselbalch equation. Okay, di ba ito yon? Denominator yan. Denominator yan nung Henderson-Hasselbalch equation natin. Wait, can you still remember the formula of the Henderson-Hasselbalch equation? Ano na nga ba yung formula ng Henderson-Hasselbalch equation? Di ba it states that your pH is equivalent to a dissociation constant, which is 6.1, usually, plus the logarithm. The logarithm of the what? Ilalagay natin sa numerator si bicarbonate, i-divide natin with your carbon dioxide multiplied by 0.03 or 0.031. Okay, so in this case, we have your bicarbonate over PCO2 over 0.031. Ito palang PCO2 multiplied by 0.031. It actually represents the carbonic acid level natin. So itong denominator ng Henderson-Hasselbalch equation is equivalent to the carbonic acid natin. So that means, ang daming binigay sa atin na given, di naman pala lahat gagamitin. All you would be needing in here pala is the PCO2. Okay, so that means we substitute it out. PCO2 natin is equivalent to 29.7. Multiply mo lang with the constant 0.031. Okay, and that would lead us to the final answer. Final answer is 0.9207. Okay, so for item number 19, the final answer, the carbonic acid level or the H2CO3 is equivalent to 0.9207. Okay, so that would be the carbonic acid level natin. However, alam niyo ba nung tinanong yan dati ng board exam, walang tamang sagot. Or yung mga student, hindi naman, may tamang sagot, pero yung mga students, hindi sila nag-arrive dun sa tamang sagot. Yung pala, ang ginamit ng mga board of examiner ay 0.03 lang. 0.03 lang yung ginamit nila. So therefore, kapag feeling nyo parang hindi kayo nag-arrive sa final answer, try nyong bawasan ng decimal places. Minsan kasi, instead of 0.031, ang gamit lang ng mga board of examiner ay 0.03. Madalas yan nangyayari sa mga conversion. Like for example, di ba ang conversion factor ng glucose natin? Conversion factor ng glucose is 0.0555 dapat. Pero minsan yung mga board of examiner, ang ginagamit nila 0.055 lang. Tinatanggal nila yung panghuling 5. So if it seems like you're not arriving on any of the choices, hindi kina-calculate mo, tama naman yung computation mo, and yet wala sa choices, yung sagot mo, try removing some of the decimal places. Okay, try removing some of the decimal places. Kasi minsan, yung mga board of examiner, minsan 2-3 decimal places lang yung ginagamit nila. Okay, just in case lang naman, no, na tama naman yung computation mo, tapos parang hindi ka nag-arrive sa final answer, lalo kapag conversion, bawasan mo lang siya ng decimal places. Which we actually did in here, in this case particularly, 0.031. Nung time na lumabas to ng board exam, 0.03 lang yung ginamit nila. So still, you just have to look for the closest possible answer. Okay, so therefore, for item number 19, the best answer natin would be for the bicarbonate. No, na-type ko na pala. We have 0.9207. Okay? Last item natin, we now have your... Okay, I hope okay na with this one. Okay, we now have the last item, which happens to be your free T4 index. This is one of the most common computation na tinatanong nila sa endocrinology. Okay, in conjunction to endocrinology, sometimes they would ask you to compute for the free T4 index. Okay, free T4 index, binigay si total T4, binigay si resin T3 uptake test result, at saka resin T3 uptake ni patient, at saka ni serum pool. By the way, recall question, si serum pool, I think nabanggit na natin tong other name ng serum pool. Yan yung tinatawag na pooled sera, di ba? Otherwise known as your control. Okay? T3 uptake of the patient over the T3 uptake of your control. That's what give us the thing na i-multiply natin sa total T4. Okay, and makukuha na natin si free T4 index. By the way, yung T3 uptake ni pasyente over the T3 uptake of control, T3 uptake of control or the serum pool, yan actually yung tinatawag nating THBR. Okay? Etong resin T3 uptake of your patient over the T3 uptake of the pool, the serum pool or the control, that would actually give us the THBR na siyang gagamitin natin to compute for the free T4 index. So ma'am, ano bang formula pala ng free T4 index? Free T4 index is actually your total T4 multiplied by the THBR. THBR, ano nga meaning ng THBR natin? The thyroid hormone binding ratio. And again, how do we get the thyroid hormone binding ratio? Ratio lang yan ng T3 uptake ni patient over the T3 uptake of your control. Okay, so nilagay naman natin sa chat box ano yung formula. Formula ng THBR, T3 uptake ni pasyente over the T3 uptake of the control, control otherwise known as the serum pool. Okay, so therefore, in this case, substitute natin. Total T4, anong value ng total T4 natin? The total T4 is 10. Mumultiply lang daw natin with the THBR, ratio ng T3 uptake ni pasyente, which is 27, with the T3 uptake of the serum pool or what we would call the control. So ito na ngayon yung working equation natin. So we have 10 times 27, that would give us 270, divided by 30, that would give us 9. So therefore, what is the free T4 index of your patient? For item number 20, that would be equivalent not to a free T4 index of 9. Okay, so that is how we solve the free T4 index. And wag kakalimutan ha, itong part na to, the T3 uptake of your control over the T3 uptake of your, or sorry, T3 uptake of your patient rather, over the T3 uptake of your control, yan yung THBR natin. T3 uptake ng pasyente over the T3 uptake of your control, that constitutes the thyroid hormone binding ratio. And i-multiply lang natin siya with the total T4 para makuha natin si free T4 index. Okay, so therefore, in this particular case, the free T4 index now would be equivalent to. Okay? So that I think is the last mathematical problem natin no, concerning the laboratory mathematics. And again, most of them are recall questions sa clinical chemistry. Although some of the questions natin may appear in other subjects such as AUBF at saka Histotech, pero at least try to be familiar with them kasi most of the laboratory calculations in there were previous na mga recall questions. Okay? Pero either way, that officially concludes the laboratory mathematics na portion ng ating discussion. Now that we're done with the general laboratory portion, alam na natin kung paano nagme-measure ng analyte, kung paano natin ine-ensure na accurate and precise yung nakuha nating analysis. The next big question is, what are the analytes? Ano-ano ba yung mga analytes na mine-measure natin in the laboratory? So again, in your notes, we have placed in there the 3 macro molecules natin. Kaso, due to the limited time that we have, we might not really be able to tackle all of them, ano? Okay, kasi medyo na-limit yung oras natin to 1 to 5 for today. Okay, hanggang 5 p.m. lang kasi tayo today. So, we'll just try to condense everything up now. Okay. Although, kompleto naman halos yung details dyan, especially when you go to lipids at saka sa proteins. Okay, pero due to the limited time that we have, we'll just try to run through some of the important details, especially what you might expect on the actual na board exam. Okay, pero let's try to deal with them. And one of the favorite topics kasi talaga sa exam no, ay ang mga sugar, or what we collectively call the carbo hydrates. Okay, carbohydrates or what we would call the sugar. Okay, so sugars are the carbohydrates. And why were they called carbohydrates nga pala? Well, from the word itself, carbohydrates. They're literally carbon na nilagyan ng tubig. Carbon na nilagyan ng tubig, hydrates of your carbon. That's why ang general formula ng mga carbohydrates natin ay C sub X quantity H2O subscript Y. X and Y can pertain to any numbers. Any number yan, si X at saka si Y. So technically speaking, they're made up of carbon, hydrogen, and oxygen. That's why they were called the carbohydrates. Literally hydrates of your carbon. And because of that, karamihan ng carbohydrates natin, most of them are in fact water soluble. Since they're practically made up of water, they do contain water. Therefore, most of them are water soluble. But the most important part about them is this last portion. Ang mga carbohydrates natin, most of them, although hindi lahat ha, most of them are reducing sugars. Most of your sugars are capable of doing the reduction, recall question except for one, and the exception is your sucrose. Huwag kakalimutan, sucrose. Sucrose is a non-reducing sugar. Ma'am, importante bang malaman yan? Well, yes, kasi babalikan natin yan later on, especially when we go to the methods natin. Mamaya, meron kasi tayong method eh. Meron tayo kasing method mamaya, yung mga tinatawag nating copper reduction, ferric reduction. Copper reduction and ferric reduction is based on the idea that most of your carbohydrates are reducing sugar. Most of the carbohydrates are reducing sugar. They are capable of doing reduction. Okay, kaso hindi niya madedetect yung mga copper reduction, ferric reduction natin. They cannot detect the sucrose because sucrose is a non-reducing sugar. Okay, so ingat ha, yung mga reduction methods natin later on, they can detect the reducing sugar. Ang hindi lang nila madedetect kasi non-reducing sugar to will be the sucrose. Okay? Pero those are the basic characteristics of your carbohydrates. But then again, in your notes, we have in there the different classifications of your carbohydrates. Nakagrupo na yan, ano? We have the monosaccharides, we also have the disaccharides, and we also have the polysaccharide. Okay, sino-sino daw yung mga examples ng mga monosaccharide natin? For the monosaccharide, we have the glucose, the fructose, and the galactose. Okay, for the monosaccharide family natin, now we have the glucose, the fructose, and the galactose. For the disaccharide naman natin, some of the examples would include your lactose, yung ating sucrose, at yung ating maltose. And finally, we have the polysaccharide na portion. Polysaccharide naman na would include your glycogen. This would also include your starch at saka yung ating chitin. Okay, so these are some of the examples of your polysaccharide. Ma'am, kailangan bang kabisado namin yung mga monosaccharide, disaccharide, polysaccharide? Well, yes. Sometimes kasi ang question is all of the following are disaccharides except kanino. Kaya kailangan alam niyo yung category nila. If they are monosaccharide ba, disaccharide, or polysaccharide. Okay? However, let's try to dig into the details. Puntahan natin si monosaccharide. One of the most important monosaccharide natin ay si glucose, which is somehow synonymous to your dextrose. Okay? And laging tatandaan, glucose is the only sugar that is readily converted by the cells of the body into energy. Sino lang pala yung direktang nako-convert ng katawan natin into energy? The only sugar pala that is readily, immediately converted by the cells of the body into energy ay itong ating glucose. Okay? Kaya usually, kapag fluid, usually if the IV or the intravenous na infusion has to contain sugar, most likely glucose ang laman nun. I think naririnig nyo naman sa mga kapitbahay ninyo, no? Minsan, kapitbahay talaga, no? Pag nakikimarites si kapitbahay, ichichika sa'yo, uy, si ganito na ospital, naka-dextrose sa hospital. Pag sinabing dextrose, no, naging generic term na sa IV fluid. Pero ingat kayo, people, ha? Hindi lahat na nakasuksok sa IV drip, puro dextrose, ha? Hindi yan palaging dextrose. Minsan, NSS lang yan. Minsan, ang laman lang niyan, antibiotic. Minsan, diuretics yung laman niyan. Iba-iba yung laman ng mga IV infusion, ha? Pero if they were to contain sugar, it would most likely be dextrose or glucose. Kasi dextrose or glucose lang naman yung nako-convert mo directly. Siya lang naman kasi ang nako-convert readily into energy. The rest of them, dadaan mo na sa pagiging glucose bago ma-convert into other or into energy. Okay, so glucose daw yung readily, immediately nako-convert ng katawan natin into energy. Okay? Another important thing, we have your fructose. Sa mga lumang libro, si fructose nga pala ay tinatawag ding levulose. Levulose, or what we would commonly hear as the fruit sugar. And usually, saan dinedetect si fructose? Bihira naman niyang i-detect sa serum eh. Usually, ang fructose, they are detected in the semen or seminal fluid. Fructose kasi, hindi naman yan dinedetect madalas sa dugo eh. Usually, if i-detect man natin si fructose, usually they're detected in the semen or the seminal fluid. Kasi this is produced by the seminal vessels of the male reproductive system. Yan kasi nagsisilbing food for the sperm cells. Okay, yan nagsisilbing pagkain ng mga sperm cell. Okay, para meron silang baon pagkain sa kanilang paglalayag. Okay, kailangan may baon daw silang food. Ang food na baon nila is the fructose, and this is produced by the seminal vessels or the seminal vesicles of the male reproductive system. And isa pang dapat tandaan about the fructose. Ang fructose, di ba, siya yung tinatawag na fruit sugar? And laging tatandaan, recall question sa fructose. Si fructose nga pala, isa sa mga recall questions sa kanya yung test. Okay, recall question. Yung isa sa mga famous na test natin for the fructose. Okay, naalala niyo pa ba yung pangalan ng test na famously ginagamit for the fructose? Okay, we have the Seliwanov test. Pero probably you're not hearing the word the Seliwanov anymore kasi nowadays ang tawag na sa kanya ay resorcinol hydrochloric acid test. Ang tawag na kasi sa kanya nowadays ay resorcinol hydrochloric acid test. Ba't ka pala siya tinatawag na resorcinol hydrochloric acid test? Kasi yun yung reagent. Okay, ang reagent kasi ay si resorcinol combined with your hydrochloric acid. So instead of calling it the Seliwanov, they ended up calling it the resorcinol hydrochloric acid na test or procedure. Okay, pero ingat kasi minsan tinatanong pa rin yung pangalan nung lumang method, especially sa AUBF, kaya you have to be familiar somehow with that. Okay? Pero either way, yan yung mga important details, no? Especially when it comes to the fructose analysis. Okay? On the other hand, or on the other side, we have the disaccharide na family. For the disaccharide, na-enumerate na natin yung mga examples. Ano? We have your lactose, sucrose, at saka maltose. And syempre, wag kakalimutan yung dalawang sugar molecule. Sugar combination ng mga disaccharides natin. No? Ang lactose, they're made up of galactose. Galactose combined with your glucose. Okay, galactose combined with your glucose, we get to have your lactose. And syempre, meron tayong sucrose, which is a combination of your fructose at saka glucose. And finally, we have your maltose. At ang maltose naman daw natin ay alin? Ang maltose naman daw natin ay glucose combined with another glucose. Okay, glucose combined with another glucose, you get to create sa maltose. Okay? And recall question, sino na nga yung non-reducing sugar natin? Famous for being a non-reducing sugar ay ang ating sucrose. And sucrose, ito yung tinaguriang table sugar. Okay, so yan yung tinatawag nating table sugar. Yan kasi yung sugar na nabibili sa mga suking tindahan. Okay, yung sugar na nabibili natin sa mga suking tindahan, we chemically call it the sucrose. Okay, sucrose, non-reducing sugar, otherwise known as the table sugar. Okay? Si lactose naman, ito naman yung tinatawag nating milk sugar. Okay, lactose is famous for being naman the milk sugar. Yan kasi yung carbohydrates that you can find sa mga dairy products such as milk. That's why they call it the milk sugar. And laging tatandaan ha, recall question. Si lactose, ito yung sugar, no? That if it accumulates, okay, if lactose daw pala accumulates in the intestines, laging tatandaan, they can cause gastrointestinal discomfort. Sino daw pala yung sugar, yung disaccharide specifically, na kapag nag-accumulate sa intestine daw, pwedeng mag-cause ng gastrointestinal discomfort? Characteristic pala yan ni lactose. Okay, characteristic pala yan ni lactose. Okay, if it accumulates in the intestine, ha, they can cause gastrointestinal discomfort. The question is why and how? Unang tanong, bakit siya nag-accumulate sa intestine? Pangalawa, paano siya nagkakos ng gastrointestinal discomfort? Now we got two questions. Una, bakit siya nag-accumulate sa intestine? Pangalawa, bakit siya nagkakos ng gastrointestinal discomfort? Now, let's try to deal with it. Okay, ganito yan. Normally, kung isa kang normal na person na madalas namang umiinom ng gatas, your body can actually digest the lactose natin. Okay, kung regular ka namang uminom ng gatas, normally, isa ka namang normal na nilalang, wala ka namang lactase deficiency, your body can actually split the lactose. Kaya nilang chop-chopin si lactose gamit ang enzyme na lactase. Okay, normally ha, ang normal na person kasi na wala namang kahit na anong problema or enzyme deficiency, a normal individual can actually chop the lactose down. Using the power of the enzyme lactase, we are able not to split the lactose into two parts, revealing the galactose and the glucose. That is, kung isa kang normal na nilalang na regularly umiinom ng gatas. Eh, what if hindi ka naman madalas uminom ng gatas? What if galit ka sa gatas? What if, like, yung huli mong inom ng gatas, eh, kunwari breast milk pa ng nanay mo, hindi ka talaga umiinom ng gatas. Okay, what do you think would happen? Laging tatandaan, kung hindi ka naman regularly uminom ng gatas, anong pwedeng mangyari? Laging tatandaan, ang katawan natin mahilig mag-cost cutting. Ang body pala natin mahilig silang mag-cost cutting. Kapag feeling nila hindi mo kailangan, di mo na niya ipoproduce. So sabi ng katawan mo, ay, di naman umiinom ng gatas itong babaeng to or itong lalaking to. Wala naman tayo masyadong na-encounter na lactose. Wag muna kaya tayo mag-produce ng lactase para tipid. Sayang yung lactase na pinoproduce natin eh. Wala namang tina-target. Wala namang lactose. So pag napapansin ng katawan mo na, uy, di ka naman uminom ng gatas, di ka masyado nakapag-intake ng lactose, they will temporary lang ha, temporarily, they will stop producing the lactase. Kasi ang katawan, mahilig yan mag-cost cutting. Kapag feeling ng katawan mo, hindi mo kailangan, hindi niya muna ipoproduce. Nagtitipid sa resources ang body natin. Kapag feeling niya, you don't need this, they won't totally produce that. Okay, pero temporary lang naman. So, anong mangyayari? Your body will temporarily stop producing the lactase. Kasi yung katawan mo, di naman nakaka-encounter ng lactose. And what if, after a long, long time of not drinking milk at all, you suddenly felt like drinking milk? What if, after a long time na hindi ka uminom ng gatas, napagtripan mong uminom ng gatas? What do you think would happen if you suddenly drink milk after a long time of not drinking milk at all? Gusto mo magpaka-healthy living, uminom ka ng gatas. Ano mangyayari? Ayan, uminom ka ng gatas, nag-intake ka ng gatas at ang gatas ay may lactose. Eh, hindi prepared yung body mo. 'Di ba nga hindi siya nag-produce ng lactase, temporarily hindi siya nag-produce ng lactase. Eh, di hindi handa yung body mo. Wala siyang lactase, walang enzyme na magcha-chop-chop kay lactose. Meaning, hindi mo mako-convert si lactose into galactose and glucose. So, ano mangyari sa lactose? Masasagot na ngayon yung unang tanong natin, mag-a-accumulate na siya ngayon sa intestine. So, bakit daw pala nag-accumulate sa intestine si lactose? Kasi walang nagcha-chop-chop sa kanya. Wala kasing enzyme, wala kasing lactase. Yung body mo kasi temporarily huminto sa pagpo-produce ng lactase. So, nung biglang dumating si lactose, hindi siya prepared, di niya ma-chop-chop ngayon si lactose. But don't worry, that's just a temporary thing. Kapag regular ka na ulit uminom ng gatas, babalik din naman ang lahat sa dati. Kapag bumalik ka sa pag-inom ulit ng gatas on a regular basis, eventually, no, your body will again produce the lactase. That is ha, granted na wala kang any genetic defect or any enzyme anomalies, for example, your body will resume the production of the lactase. But for sure, it will take time. It will take time before your body would get used to it. Okay, kaya mas maganda kung matagal kang hindi uminom ng gatas, tapos gusto mo ulit uminom ng gatas, unti-unti muna. For example, start ka muna with 50 ml, tas unti mong i-increase yung amount so that your body will get used to it. Okay, para yung katawan mo, maisipan niya ulit mag-produce ng lactase. Pero bottom line, nasagot na natin yung unang tanong, no, kung bakit nag-accumulate si lactose in the intestine. Pwede siyang mag-accumulate, especially kapag walang lactase that is supposed to chop them down. Okay? However, pangalawang tanong, bakit magkakaroon ng gastrointestinal discomfort? Okay, ma'am, alam na namin na pwedeng mag-accumulate si lactose. Eh, bakit siya connected sa gastrointestinal discomfort? Ganito yan. Ano bang meron sa intestine natin? Intestine, di ba nandyan yung ating friendly neighborhood bacteria? Sa intestine, dyan mo matatagpuan ang mga normal flora, mga resident flora. And di ba sa microbiology, ilan sa mga organism, ilan sa mga organism na pwede mong makita sa intestine, normal flora sa intestine is yung ating acronym na ECE. Ano nga meaning ng eke? We have the Escherichia coli, we have Klebsiella na pwede mo makita sa intestine din, at saka si Enterobacter. Okay, we collectively call them the eke. Okay, so sila yung tinatawag nating eke. Okay, ano bang karakteristik ng eke na yan, ma'am? Ano naman ngayon, ma'am, kung makikita sila sa intestine, naalala niyo ba yung characteristic ni E. coli, Klebsiella, at saka Enterobacter? Di ba they're famous for being rapid lactose fermenters. Rapid, mabilis silang mag-ferment ng lactose. Okay, ma'am. Ano naman ngayon kapag mabilis silang mag-ferment ng lactose? Okay, ano-ano bang lalabas kapag nag-ferment ng lactose? Ano nga ba yung mga products ng fermentation natin? Laging tatandaan, kung naalala nyo pa sa TSI, ano bang nangyayari sa itsura ng TSI kapag rapid lactose fermenter or lactose fermenter ang organism natin? Okay, laging tatandaan, lactose fermenter, anong characteristic nila sa TSI? Una, they produce A over A, right? Kapag lactose fermenter, they would give off an A over A. And what is the meaning of A over A? Acid slant over acid butt. In short, ano yung kauna-unahang napoproduce kapag nagfe-ferment ng lactose? They would produce acids. One of the products of lactose fermentation will be acid. Ano naman ngayon, ma'am, kung acid? Ito yung reason kung bakit kapag nagda-diarrhea ka after drinking milk, after a long time of not drinking milk, napagtripan mong uminom ng gatas, maya-mayang konti, magda-diarrhea ka na. And yung diarrhea mo, medyo mahapde ang sensation. Ma'am, bakit nagiging mahapde? Kasi acidic yung stool mo. Bakit naging acidic yung stool? Kasi product ng lactose fermentation ay acids. So that explains the painful sensation whenever you're having diarrhea after drinking milk. Okay, acidic kasi yung lumalabas na stool. Normally, ang pH ng stool nasa 7.0 to 8.0 lang. Okay, kaso because of the production of the acid brought about by the lactose fermentation, pwedeng maging acidic yung ating stool. Okay, so therefore, in that case, magkakaroon ng acid as a product of fermentation. Aside from that, minsan ang mga lactose fermenter natin nagpo-produce ng displacement, ng mga cracks, at ng mga bubbles. Anong ibig sabihin pag may displacement, may cracks, or may bubbles sa TSI natin? Sa triple sugar iron agar, di ba? Pag may cracks, may bubbles, may displacement, this would be a sign of gas production. Okay, di ba sa TSI nagkakaroon ng cracks, displacement, bubbles, senyales yan na may gas production. So gas production is also a product of lactose fermentation. Now that explains the reason behind the bloated feeling that you get. After a long time of not drinking milk, bigla mo na pagtripang uminom ng gatas, eventually you get to feel bloated. Feeling mo ang daming hangin sa tiyan mo. Yung tipong akala mo natatay ka na, yung pala nauutot ka lang. Or pwede ring opposite, no? Akala mo nauutot ka lang, yung pala utot mo may kasama ng tae. Okay, akala mo nauutot ka lang, natatae na pala at the same time. Okay, so yung mga tipong ganon. Kaya naman laging tatandaan, bakit may gas? Bakit may gas production na nagaganap? Again, blame it all on the bacteria inhabiting your intestine. Sila kasi yung nagfe-ferment ng lactose na nag-accumulate inside your intestine. Okay, so therefore, yun pala yung reason kung bakit may gastrointestinal discomfort. May gas, may acidic na stool, all because of the lactose fermentation. So therefore ha, recall question. Sino daw pala yung sugar na kapag nag-accumulate sa intestine, pwedeng mag-cause ng gastrointestinal discomfort? Characteristic yan ni lactose. Okay, so that should be the important detail na concerning the lactose natin. But then again, we still have the last part. We have the family of the polysaccharide. And the most important part of the list is your glycogen. Uy, glycogen. Favorite recall question. Ano na nga ba si glycogen natin? Glycogen is the storage form of glucose in the body. Storage form of glucose in the body. And ma'am, where do we store the glycogen? Where do we usually store the glycogen? They're usually stored in two main compartments of the body. They're stored in the liver and also in the muscles. You can find them in the liver, you can find them in the muscle. At si glycogen ang dahilan kung bakit pag nag-fasting tayo, di naman tayo agad nadidedo. Pag nag-skip tayo ng meal, di naman tayo agad namamatay kasi yung katawan natin nag-save ng glucose. Okay, nag-save ng glucose. Okay, so nag-save ng glucose yung katawan natin in the form of glycogen. Para mag-fasting ka man, malipasan ka man ng gutom, at least may mariretrieve tayo. Meron tayo ulit makukuha ng mga source ng energy. Okay, in the form of glycogen. Okay? Another important thing, si chitin. Si chitin is a recall question, pero usually makikita nyo to sa mycology. Si chitin kasi, ito yung polysaccharide na pwede mo makita sa cell wall ng alin? Cell wall ng mga fungi or fungi, whichever way you want to pronounce it. Cell wall ng mga fungi or ng mga fungi, we have the chitin. Okay, you can find them in the cell wall ng ating mga fungi. Okay, and that is also considered as a polysaccharide. Okay? Pero either way, try to be familiar ha, particularly with the monosaccharides at mga disaccharides natin. And together with what we have mentioned on the chat box na rin nakalagay kasi sila yung mga important details about the carbohydrates natin. Okay? However, yung madalas nating kinakain, mga tinapay, mga kanin, they're usually in the form of polysaccharide. Okay? Di ba usually yung kinakain natin, kadalasan they are in the form of polysaccharide. So, ma'am, akala ko ba ang nakakain lang ng cell ay glucose? Ang nako-convert lang ng cell into energy, glucose, ma'am. So, ma'am, paano natin china-chop-chop yung mga kanin, yung mga tinapay na kinakain natin? How do we convert them into monosaccharides para ma-convert ng mga cells natin into energy? So this time, pag-usapan natin ang tinatawag na carbohydrate regulation, carbohydrate metabolism. Paano ginagamit ng katawan natin yung mga tinapay, yung mga kanin na kinakain natin? How do we actually consume? How do we actually metabolize and regulate na rin the carbohydrate inside the body? Okay, so this time, pag-usapan natin carbohydrate metabolism and regulation. But before that, can we have a bit of a break muna? 10 minutes na break muna before we proceed with the continuation of the discussion. So real quick na bladder break lang before we proceed. Okay, 10 minutes lang kasi hanggang 5 p.m. lang naman tayo, no? Okay, by the way, kasi due to the limited time, baka hindi rin natin matapos yung notes natin, no? Pero at the end of the kasi kahapon lang din ako na-inform na yung morning pala quiz ninyo. Okay, so technically, I wasn't aware na baka possible na hindi natin matapos yung entire notes natin. Pero don't worry, yung latter part naman ng notes natin is somehow complete naman na for your reading and for your reference. So we'll just try to squeeze in the important details no, that we still have to take in. And yung mga additional na details, especially those that appeared now on the board exam. Kayo na lang hopefully yung i-cover natin along the way. Okay, pero before that, real quick na bladder break muna before we proceed with the continuation. Okay, so thank you. See you in 10 minutes.
Hello. Okay, so I hope nakabalik na lahat. Okay, resume tayo ng discussion. So this time we'll try to talk about the carbohydrate regulation, carbohydrate metabolism. So what's happening to the food that we eat? Paano ba siya maintain ng katawan natin? Paano ba siya ginagamit ng katawan as a source of energy? Okay, so dito pag-usapan natin. So for example lang naman, kunwari lang naman, ha? Kunwari kumain ka ng burger kanina. Okay, kunwari lang naman. Okay, kunwari kumain ka ng burger kanina. And syempre yung burger may tinapay. That means meron siyang carbohydrates. After all, bread I consider to contain carbohydrates. And how are we supposed to use the burger as a source of energy? Paano ba natin ginagamit si burger as a source of energy? Syempre, kailangan makapasok muna sa katawan natin yan, no? And one, or the only way rather, for that to go inside the body is syempre through the mouth. Okay, so I do hope wala namang ibang portal of entry, no? Aside from the mouth. Pero either way, para magamit natin si burger as a source of energy, kailangan makapasok muna siya sa loob ng katawan natin, and that would be through the mouth. Now, the question is, nag-i-start na ba ang carbohydrate digestion in the mouth? Nag-uumpisa na ba ang carbohydrate digestion in the mouth? The answer is yes, kasi after ang mouth natin ay may saliva, at ang saliva natin ay may enzyme. And one of the enzymes that you can find in the saliva ay si salivary amylase. Sa lumang libro, tinatawag siyang thiolin or pithiolin. Bahala na kayo paano siya ipopronounce. Pero thiolin or pithiolin, this would be the other name of salivary amylase. At ito pala yung unang-unang makakasalubong ng pagkain, ano, the moment they enter through the mouth natin. At dito pa lang, mag-uumpisa na yung carbohydrate digestion. In the mouth pa lang, no, with the help of the salivary amylase, we can already split down the carbohydrates into smaller molecules. However, although yes, it begins in the mouth, it doesn't really end in the mouth. Kasi real talk, gaano ba katagal nagtatagal ang pagkain sa mouth natin? Minsan, ilang waya lang, nilulunok na natin agad yung pagkain. Minsan nga, hindi pa nakakadikit si amylase dun sa pagkain, nalunok mo na agad yung pagkain. Di man lang nabigyan ng pagkakataon si amylase no, na makipag-bonding dun sa kinain mong burger, nalunok mo na agad yung pagkain. So therefore, although yes, it begins on the mouth, unfortunately, hindi talaga truly na-chop-chop yung carbohydrates in the mouth. Okay, kasi minsan yung food, hindi siya nagtitatagal sa mouth. Okay, usually after chewing it 1, 2, or 3 times, we automatically swallow the food down from the mouth, down to the esophagus, papunta sa ating stomach. Okay, ma'am, matutuloy na ba sa stomach yung carbohydrate digestion? Unfortunately, walang carbohydrate digestion na magaganap sa stomach. Ma'am, bakit? Well, kasi ang stomach natin ay may gastric acid at ang gastric acid natin contains hydrochloric acid. At ang pH ng hydrochloric acid natin sa stomach ay kumukulo-kulo. Gaano ba katindi ang hydrochloric acid natin sa stomach? Usually, they would have a pH of around 1.0 to 3.0, which is very, very acidic. To the point na ang nangyayari, nasisira yung amylase. Ang amylase, they cannot withstand the acidity of the stomach natin. So therefore, nai-inactivate yung salivary amylase natin once they reach the stomach. So kapag walang amylase, di mo machachap-chap si carbohydrates. So therefore, temporarily, mahihinto ang carbohydrate digestion sa stomach kasi nandiyan naman sa notes natin, no? The acidity of the hydrochloric acid inactivates the salivary amylase. Teka ma'am, kung walang carbohydrate digestion sa stomach, bakit pa naging digestive organ yung stomach natin? Ma'am, sa anatomy and physiology, sabi, si stomach daw yung digestive organ. Bakit pa siya naging digestive organ, ma'am? Kung wala naman palang carbohydrate digestion na nagaganap sa stomach. Okay, laging tatandaan ha, walang carbohydrate digestion sa stomach kasi something else is being digested in the stomach. Usually, ano ba ang nadadigest sa stomach? Kadalasan protein ang nadadigest sa stomach. Yung karne, yung protein content ng pagkain na kinakain natin, yun yung nadadigest sa stomach. Pero kung usapang carbohydrate, kadalasan walang carbohydrate digestion na nagaganap sa stomach. Again, due to the acidity kasi of the gastric fluid natin, nai-inactivate si salivary amylase. So, temporary, may hinto ang carbohydrate digestion of the stomach. So, ma'am, kailan mare-resume yung carbohydrate digestion? So, after passing through the stomach, the food will now eventually end up in the small intestine.
At sa small intestine, matutuloy na yung naunsaming process, matutuloy na yung naudlot na proseso ng carbohydrate digestion. In the small intestine, machachap-chap na yung mga polysaccharides natin into monosaccharide. Teka ma'am, sinong gagawa ng pagchachap-chap? Di ba wala na tayong salivary amylase? Killed in action yung salivary amylase, killed by the acidity of the stomach. So ma'am, sino magtutuloy ng sinimulan ni salivary amylase? Itutuloy yan nung kakambal niyang amylase. Sino ba yung kakambal ni salivary amylase? Meron pa tayo kasing isang amylase, si pancreatic amylase, which is otherwise known as amylopsin. So si pancreatic amylase ang magtutuloy ng sinimulan ni salivary amylase. Okay, so dito, since nawala na si salivary amylase, nasira na siya ng acidity ng ating stomach, itutuloy ni pancreatic amylase ang proseso. So pancreatic amylase will eventually chop down the polysaccharides into monosaccharides. Okay, so galing yan sa pancreas. From the pancreas, magta-travel yan dun sa common bile duct papunta sa intestine natin. Okay? And eventually, chachap-chapin niya daw si polysaccharide into monosaccharide. And mama, anong gagawin natin sa mga monosaccharide na yan? Remember, si small intestine, sa anatomy and physiology, ang small intestine natin, they're famous for being what? They're famous for being the organ of absorption. Organ of absorption yan, si intestine. Ia-absorb niya ngayon yung mga na-chop-chop, yung mga monosaccharide na yan. Ia-absorb niya yan. Pag sinabing ia-absorb, from the small intestine, dadalhin niya yan sa blood or sa circulation. Okay, papasok yan ngayon sa circulation natin from the small intestine. And ano mangyari ngayon sa sugar sa dugo natin? After ma-absorb ni small intestine yung mga sugar, yung mga monosaccharide, especially yung mga glucose na nasa small intestine, mapupunta na yan ngayon sa blood. Ano mangyayari sa glucose ng blood natin? Tataas yan ngayon. Anong tawag natin? Anong tawag natin sa pagtaas ng sugar na yan? After nating kumain, ang clinical term dyan ay transient postprandial hyperglycemia. Anong ibig sabihin pag sinabing transient postprandial hyperglycemia? Pag sinabing hyper, tataas ang alin? Ang glucose, glyce pertaining to glucose, emia in the blood. Kailan daw yan? Postprandial. Pag sinabing post, after. Prandial means eating. After eating. Okay, ano daw mangyayari after nating kumain? Tataas daw ang glucose natin in the blood. We call it the postprandial hyperglycemia. Pero ingat, transient lang daw. Pag sinabing transient, temporary lang. They should only cause an increase in the sugar in the blood temporarily. Hindi pwedeng matagal na mataas ang glucose natin in the blood, ha? Dapat after kumain, tataas yung glucose natin, pero dapat temporary lang. By the way, usually ilang minuto yan nangyayari or ilang minuto after kumain nagaganap si transient postprandial hyperglycemia. Usually nangyayari yan around 30 minutes after nating kumain. So 30 minutes after nating kumain, expect na tataas ang sugar natin in the circulation. Expect na magkakaroon ka ng postprandial hyperglycemia 30 minutes after kumain. Pero syempre, sabi natin, dapat temporary lang yan. Hindi dapat palagi or matagalang mataas ang glucose natin in the blood. Bakit? Normally, ano bang ginagawa ng katawan natin pag nakita niyang, uy, ang taas ng sugar nito? Dapat ma-activate si pancreas. Okay, anong gagawin ng pancreas natin? Pag nakita ni pancreas na, uy, mataas ang glucose natin in the blood, sabihin ni pancreas, aba, hindi tama to. Kailangan ibalik natin sa normal yung glucose natin. So, ano gagawin ngayon ng pancreas natin? Magpo-produce siya ngayon ng hormone na makakapagpababa nung mataas nating glucose. Kailangan mo siyang ibalik sa normal eh. So, anong gagawin mo para bumalik sa normal? Yung mataas, pabababain mo. Ano gagawin natin para mapababa yung ating blood glucose? Magpo-produce ngayon si pancreas ng pampababa ng sugar. We call it a hypoglycemic agent. And sino nga ba yung hormone that can serve as a hypoglycemic agent? That can lower the elevated blood glucose natin? We would call that your insulin. So kapag natunugan ng katawan mo na, oy, mataas ang glucose, kailangan nating ibalik sa normal yan. Anong gagawin ng pancreas natin? Si pancreas, magpo-produce siya ngayon ng pampababa ng sugar sa blood. And sino nga ba yung hormone that can lower the glucose levels in the blood? That would be your insulin. And speaking of the insulin, recall question, insulin, una sa lahat, it is a hypoglycemic agent, meaning it is an agent that can lower the blood glucose levels. And they are produced by the pancreas. To be more specific, they are produced by the beta cells of the pancreas. However, laging tatandaan ha, ang beta cells ng pancreas, hindi naman nagadagad insulin ang pinoproduce niya. Usually, ano muna ang pinoproduce ng pancreas? Usually, the pancreas would first produce the proinsulin. Uy, meron pa yung pro sa unahan. Usually, kapag may pro pa sa unahan, inactive pa yan. Okay? Kadalasan, kapag may pro pa sa unahan, usually, they would mean that the substance is still in the inactive na state. However, di naman natin magagamit yan kung inactive yan. Kailangan i-convert natin yan into the active form. And sino nga bang active form ni proinsulin? Siyempre, it would be the insulin. Which leads us to the recall question. Recall question. Sino daw yung fragment na tatanggalin natin? Sino daw yung fragment na tatanggalin natin para ma-convert si proinsulin into the insulin? Sino daw yung fragment to be removed para si proinsulin ay maging insulin? Laging tatandaan, we will have to remove the C-peptide. Tatanggalin. Uy, ingat ha. Si C-peptide, hindi siya yung active form ha. Siya yung tatanggalin mo para si proinsulin ay maging insulin. So, ano daw pala yung fragment na tatanggalin natin para si proinsulin ay maging insulin? Ingat kayo, hindi pro ha. Baka sabihin nyo, pro na lang ang tanggalin para si proinsulin ay maging insulin. Laging tatandaan, ang tatanggalin is the so-called C-peptide. Okay, recall question yan, si C-peptide. C-peptide, no, is the fragment to be removed. Okay, so fragment to be removed para ma-convert natin si proinsulin to convert the proinsulin into insulin. Okay, so to convert the proinsulin into insulin, we need to remove a certain fragment, and that fragment is your C-peptide. Okay, so recall question yan ha, so try to be at least familiar with it. Okay, pero either way, ayan na ma'am, meron na tayong insulin. And insulin is capable of lowering the blood glucose level. So next big question is how? How can the insulin lower the blood glucose level? Paano napapababa ni insulin ang glucose levels natin? Laging tatandaan, nandiyan na sa notes natin, may tatlong action. May tatlong action ang insulin natin para mapababa yung glucose natin in the blood. Okay, ano yung tatlong action ng insulin natin in order to lower the blood glucose levels natin? So I think nandiyan na sa notes natin, no? Laging tatandaan, insulin, gagawin muna nila yung kanilang plan A. Ano daw pala ang plan A ng insulin natin? Ano daw pala yung kauna-unahang gagawin ng insulin natin para mapababa? Plan A, they will first have to do the alin? Magpe-perform daw sila ng plan A. They will increase the cellular uptake of your glucose. Ano daw? Ano daw yung gagawin? Ano daw yung gagawin ng ating insulin? They will increase daw the cellular uptake of your glucose. Okay, so ano ibig sabihin nun? Okay, ito yan. Di ba 30 minutes after natin kumain, ang glucose natin sa plasma, ang glucose natin sa blood ay tataas. Okay, so laging tatandaan ha. Di ba 30 minutes after natin kumain, you get to have a postprandial hyperglycemia. Mag-i-increase ang glucose levels natin in the blood. Pero syempre, di daw hahayaan ng katawan natin na forever mataas ang glucose levels natin in the blood. Anong gagawin ng katawan natin? Pabababain niya yung glucose na yan. Ano daw yung unang gagawin ng insulin para mapababa? Yung glucose na yan na sa plasma. Plan A, they will increase the cellular uptake or pagpasok. Pagpasok ng glucose sa loob ng ating mga cell. Ang gagawin daw pala ni insulin, tutulong daw pala siya para maitulak papasok sa loob ng cell. Tulak papasok sa loob ng cell yung ating glucose. Kasi nga naman, pag pumasok ng pumasok yung glucose sa loob ng cell, ano mangyayari sa glucose mo in the plasma? Eventually, bababa yung glucose levels natin in the plasma. So, ang una palang gagawin ni insulin, itutulak niya yung mga glucose na yan na nasa plasma, papapasukin niya ng papapasukin sa loob ng cell para yung glucose sa plasma ay eventually bumaba. Okay, so therefore, ma-achieve niya yung goal niya as a hypoglycemic agent. However, bakit nga pala kailangan pumasok yung glucose sa loob ng cell natin? Why do they have to enter the cell? Kasi kailangan silang makapasok sa loob ng cell para magamit sila ni cell as a source of energy. So, para magamit ni cell as a source of energy yung ating glucose, they have to first enter the cell. At ang tumutulong pala para makapasok si glucose sa loob ng cell ay si insulin. However, laging tatandaan, for this thing to actually happen, may dalawang requirements. Ano daw pala yung dalawang requirement para makapasok si glucose sa loob ng cell? Simple lang naman, kailangan mo ng susi at kailangan mo ng pintuan. Kailangan mo ng susi at kailangan mo ng pintuan. Uy ma'am, sino ang magsisilbing susi? Who will serve as the key? At sino yung tatanggap ng susi na yon? Okay, laging tatandaan, ang susi ay si insulin. At ang tatanggap ng insulin, we would call it, syempre, the insulin receptor. Whenever you hear the word receptor, it would always mean something that receives, something that accepts. So pag sinabing insulin receptor, isa siyang receptor na tumatanggap ng insulin. So meron tayong susi, which is the insulin, at meron tayong pintuan, which is the insulin receptor. When the key meets the door, ma-unlock na natin yung door. Makakapasok na si glucose sa loob ng cell. Bababa na ngayon yung glucose natin in the plasma. So yun pala yung action ng insulin, no? At para magawa pala ni insulin yan, kailangan mo hindi lang ng insulin, kailangan mo rin ng insulin receptor. Now, here comes the problem. May mga tao kasi na tumataas yung glucose nila sa plasma. Bakit tumataas yung glucose nila sa plasma? Hindi kasi makapasok sa loob yung glucose. Bakit di makapasok sa loob ng cell yung glucose? Dalawa lang yan. Either wala kang susi or baka naman may susi, sira naman ang pintuan. Minsan ang problema, wala kang susi. Minsan ang problema, sira yung pintuan. Aanhin mo nga naman ang susi nang wala kang pintuan. So therefore, it's one of two things. Either way, tataas ang glucose natin pag wala kang susi, wala kang insulin. Now, what do we call the condition? Kapag ang problema mo ay nasa susi, kapag ang problema mo ay nasa insulin, we usually call it the type 1. Diabetes mellitus. Kapag ang problema mo ay nasa insulin, wala kang susi, edi sarado lahat ng pintuan, di makakapasok si glucose. San may ipon yung glucose? May ipon sa plasma. Yung glucose mo, you would end up having diabetes, you would end up having hyperglycemia. Okay, kapag ang problema ay nasa susi, nasa insulin, we call it your type 1 diabetes mellitus. Ma'am, paano pag may susi? Sira naman yung pintuan. Ma'am, paano pag ang problema ay nasa pintuan, nasa insulin receptor? Uy, recall question yan. Anong tawag natin kapag ang defect ay nasa insulin receptor? We would call it the type 2 diabetes mellitus. Okay? So therefore, ano palang difference ni type 1 kay type 2? Depende kung nasa susi or nasa pintuan ang problema. Okay, if the problem is on the insulin, we call it your type 1. But if the problem is on the insulin receptor, we would call it a type 2 diabetes mellitus. Pero either way, problema man sa susi, problema man sa pintuan, still, ano mangyari sa glucose mo? Maiipon yan ngayon sa plasma. Magkakaroon ka ng hyperglycemia. Kaya common characteristic ng diabetes mellitus, pag diabetes mellitus, expect that there would always be hyperglycemia. Hindi kasi makapasok sa loob ng cell kasi either wala kang susi or sira ang pintuan. Okay? Pero either way, yan pala yung unang action ng insulin, no? If everything goes well naman, makakapasok naman si glucose sa loob ng cell natin. Okay? Ang nagiging problema lang talaga is minsan pag wala kang insulin or pag defective yung insulin receptor. Okay? Pero yan yung dalawang requirements so that your insulin would be able to do the plan A, Plan A is to increase the cellular uptake of your glucose. Now, this is now the reason why people with diabetes would have three typical letter P's. Familiar pa ba kayo sa three P's ng diabetes mellitus? Okay, ano ba yung tatlong P's ng diabetes mellitus? Actually, sa mga latest na libro, apat na daw yan eh. May polyneuropathy pa sila. Pero either way, apat yan. Pero dito for the meantime, tatlong P's lang muna ang pag-usapan natin. Una, we have the polyphagia, wherein kain si pasyente. Apart from that, meron din tayong tinatawag na polydipsia, wherein inom ng fluid, ng liquid, ng water si pasyente. And syempre, since inom siya ng inom ng tubig, expect that there would always be the third letter P, the polyuria. Okay, ihi naman sila na ihi. However, ang bibigyan natin ng focus dito is yung unang letter P, polyphagia. Have you ever wondered why people with diabetes, why would they still eat a lot? Bakit kain pa rin sila ng kain? Polyphagia meaning increase eating. Kain pa rin sila ng kain. Bakit nga pala kain pa rin sila ng kain? Eh, ang dami na nilang glucose sa plasma ah. Ma'am, ang dami na nilang glucose sa plasma. Why are they still eating a lot? Ginusto ba talaga nila yon na kumain ng kumain? Actually, no. It's actually your body's response. Ma'am, anong ibig mo sabihin pag sinabing body's response? Ganito yan. Okay? Di ba ang problema natin, tumaas ang glucose mo sa blood, sa plasma. Ang problema kasi, di makapasok si glucose. Hindi makapasok si glucose sa loob. So, ano mangyari kapag hindi makapasok si glucose sa loob? Siyempre, gutom. Gutom ang aabuti ng cell mo o wala silang glucose, hindi nakapasok si glucose. Gutom ang aabuti ng cell mo, wala silang pagkukunan ng energy. Anong gagawin ng cell mo 'pag nakita niyang, "Uy, wala kaming nakakain na glucose." Anong gagawin niyan? Aba'y magsusumbong yan kay brain. Magsusumbong yan kay brain. Sasabihin niya kay brain, "Uy, brain, wala tayong makain, taggutom na ba?" Okay, sabi ng cell, "Wala kaming nakukuhang glucose." Sabi nila kay brain, "Uy, ano ba, baka gusto mong kumain, brain." Okay, baka naman gusto mong kumain. Kasi walang nakukuha, walang nakakain, walang nakakapasok na glucose dun sa loob ng cell. Eh di syempre anong ginawa ni cell, nagsumbong sa brain mo. Okay, nagsumbong dun sa brain natin, sabi ni cell, "Uy, brain, baka gusto mo kumain." Ano naman gagawin ni brain ngayon? Akala ni brain walang pagkain. Eh, in fact, napakadaming pagkain. Okay, napakadaming pagkain. Ang problema lang, hindi nakakapasok yung pagkain. Hindi nakakapasok yung pagkain. So, ano nangyayari? Ang dami mong glucose sa plasma. Ang problema, di nakakain yung cell. Eto namang cell mo, sumbongera. Ang nangyari, walang makain. Nagsumbong kay brain. Ano naman tong nangyari kay brain? Panic mode. Panic mode naman si brain. Ano nangyari? Akala niya walang pagkain. Nag-trigger tuloy siya ng hunger sensation. Okay, nag-trigger tuloy siya ng hunger tendency. Anong gagawin mo kapag yung brain mo nagdesisyon, pala desisyon yung brain mo, no? Nag-decide na, uy, kailangan mo kumain. Wala daw pagkain, sabi ng cell, na-trigger tuloy yung hunger sensation. Syempre, ang tendency is kakain ka na. Kakain. Anong mangyayari? Anong mangyayari? Eventually, tataas yung glucose natin in the plasma. Okay, ang problema, marami kang glucose sa plasma. Ang tendency is Ang tendency is hindi sila makapasok sa loob ng cell. Okay? Dito, tendency is hindi makapasok sa loob ng cell. Kasi nga, either wala kang susi or wala kang pin. Okay, parang gano'n. So therefore, yun pala yung reason behind the polyphagia na kung bakit kain pa rin ng kain yung mga taong diabetic. Okay, kain pa rin sila ng kain kasi yung cells kasi nagsusumbong sa brain, si brain naman panic mode, nag-trigger ng hunger sensation, akala kasi ni brain walang pagkain, pero in fact, ang dami na palang glucose sa plasma. Ang problema lang talaga is nasa part na 'to, eh, hindi lang makapasok yung glucose sa loob ng cell. Okay, pero that is actually the rationale behind the polyphagia. That's why people with diabetes, they tend to eat and eat a lot, despite having a lot of glucose in their plasma. Okay? Another important thing, what if? Okay, ma'am, what if nakadalawang burger ako kanina, ma'am? Nakadalawang burger ako kanina, ma'am, ang dami kong glucose sa plasma. Ma'am, what if busog na yung mga cells ko? What if hindi na nila kaya? Di na nila kayang kumain, ma'am. Bundat na yung mga cells ko, ma'am. Di na nila kayang kumain pa ng glucose. Kaso, ma'am, ang dami ko pang glucose eh. Ang dami pang glucose sa plasma. What am I supposed to do to the excess glucose that could no longer be ingested by the cell? Di na kayang kainin ng cell, ma'am. Busog na yung mga cell ko. Puputok na yung tiyan ng mga cells ko, ma'am. Hindi na nila kayang kumain pa ng glucose. Eh kaso ma'am, ang dami ko pang glucose sa plasma. Anong gagawin namin ma'am pag hindi na kaya ni Plan A? In case the plan A fails, your insulin will now proceed to the plan B. Ano naman daw ang plan B ng insulin natin? Kapag pumalpak na si plan A, uy, magkakaroon na daw ng plan B. Ano daw yung plan B? They will now have to promote the glycogenesis. Ma'am, what is glycogenesis? It's actually derived from a compound word, glycogen plus genesis. Genesis means, Genesis, first book in the Bible, creation. Creation. Diyan naganap yan sa Genesis na book portion ng Bible. So we have creation happening on Genesis. So when you say Genesis, it actually means synthesis or creation. So pag glycogenesis, meaning magke-create ka ng glycogen. So ano palang gagawin natin sa excess glucose? The excess glucose that would no longer be eaten by the cells of your body, they will be converted into polysaccharides. They will be converted into glycogen. And what are we again supposed to do with the glycogen? They will be stored. Stored where? They will be stored in the liver and in the muscles natin. So in case may excess kang glucose at hindi na sila kayang i-consume ng cells natin, your insulin will now deposit them in the liver and in the muscles in the form of glycogen. Okay, so therefore, yan pala yung gagawin ng insulin natin, no? In case lang talaga, okay, in case lang na sobrang dami talaga ng glucose sa plasma, they will try to convert them into glycogen. They will temporarily store them in the liver and in the muscles. Eh, ma'am, let's add another twist to the story, ma'am. What if nakasampung burger ako kanina? Only burger pala, ma'am, yung napasukan ko kanina. Okay, nakasampung burger ako, ma'am. That means ang dami kong glucose currently in my plasma. Ma'am, what if apaw na? Sobrang dami na ng glycogen in the liver and in the muscles. What if we cannot store them in the liver and in the muscles anymore? What are we supposed to do to the excess glucose na hindi na kayang kainin ng cell, di na rin kasya sa liver, di na kasya sa muscle, apaw na, sobrang dami na ng glycogen sa liver and sa muscles, wala nang space, ma'am. What are we supposed to do with excess glucose? Dito ngayon papasok yung pinakamalagim na action ng insulin. Ano daw pala yung pinakamalagim na action ng insulin natin? They will have no choice but to do the lipogenesis. Uy, from the word itself, lipolipids and genesis. Magke-create ka na ngayon ng lipids, particularly in the form of triglycerides. Okay, they will now create, those glucose will now be converted into lipids, particularly into triglycerides. And where are we supposed to store those triglycerides? They will now be stored in the form of adipose tissue. They will now be stored in the form of adipose tissues. They will now be deposited in the abdominal region natin, sa thigh part and leg part natin, sa mga braso natin, and so on and so forth in the form of adipose tissue. So yan pala yung pinakamalagim na plano ng insulin. If all else fails, eventually your insulin will have to convert all of those glucoses into lipids. Therefore, according to study, what is still the best form of diet? What would still be the best way to do a proper diet? Laging tatandaan, exercise alone will never be enough. Exercise alone will never be sufficient. Kasi real talk, gano'ng kadaming calories ba ang nalulose mo during your exercise day? Mataas ang chance na yung calories na nalulose mo, kakain mo rin paglabas mo ng gym. Okay, hindi po nag-treadmill ka ng ganitong ilang oras, ganyan. Paglabas mo, fast food naman yung nakainan mo, wala din. Nag-quits lang. Nag-quits lang yun na metabolize mo dun sa kinain mo afterwards. So technically speaking, exercise alone will not really be sufficient. You always have to combine it with proper diet. Proper diet and exercise, not exercise alone. You always have to combine it with proper diet. And when you say proper diet, it will be consisting of both the quantity and the quality. Okay, quantity and quality. Particularly the quantity, no, limit lang. Limitation is the key. Limit the food that you take. Hanggang sa mabusog lang yung cells mo, okay na yon. Hanggang sa magkaroon ka ng glycogen, okay na yon. Huwag mo nang hayaang umabot pa ng plan C. Huwag mo na hayaang maging lipids pa yung excess glucose na yan. Okay? Kasi pag naging lipid na yan, lipids, they're easy to form but they're hard to get rid of. Ang lipids, napakadali niyang gawin. As in, real talk, ang bilis madagdagan ng timbang, napakahirap magbawas ng timbang. Bakit nga pala ganun? Bakit ang bilis-bilis nating madagdagan ng timbang pero ang hirap? Ang hirap magbawas ng timbang. Bakit? Ang lipids kasi ay heat stable. They are very, very heat stable. To the point na nag-zumba ka na isang buong araw, feeling mo hindi ka nabawasan ng timbang. Okay, hindi ka man lang nabawasan ng timbang. Okay, di ka man lang nabawasan ng timbang. Bakit? Ganun ka-stable yung lipids natin. They are very, very easy to form but they're totally hard to get rid of. Therefore, wag mo nang hayaan maging lipids pa yung excess glucose na yan. Therefore, limitation is the key. Again, exercise alone will never be sufficient. You always have to combine exercise with proper diet. However, it's easier said than done. Tama ba? Ang daling sabihin pero napakahirap gawin. Furthermore, minsan depende rin sa sitwasyon. Ingat kayo ha, hindi naman lahat ng taong obese ay obese dahil matakaw sila. Okay? Huwag kayong masyadong judgmental. May mga tao na hindi sila obese dahil matakaw sila, may mga taong obese sila dahil sa hormonal issues. Okay, minsan dahil sa hormones. Kasi laging tatandaan, kahit gaano katinding diet ang gawin mo, kung ayaw naman ng mga hormones mo na mabawasan ka ng timbang, eh wala kang magagawa. Okay? Kung hormones mo ang kalaban, mahirap. Mahirap magbawas ng timbang kapag hormones na ang kalaban. Okay? Kapag hormones na ang kalaban. Okay? Paano hormones na ang kalaban? Minsan may mga tao Okay, may mga tao na, for example, may hypothyroidism. Ang thyroid hormones kasi, importante yan para ma-convert yung food natin into energy. Okay, ang thyroid hormones, tumutulong yan, sina T3, si T4. Kailangan yan para ma-convert yung kinakain natin into energy. Eh ma'am, what if meron kaming hypothyroidism? What if mababa yung thyroid hormone levels namin? Eh di ano mangyari? Tendency, hindi mo mako-convert yung food into energy. Pag konti yung thyroid hormone mo, hindi mo mako-convert yung food into energy. So, ma'am, anong mangyari doon sa pagkain na kinain namin? Anong mangyari? Di mo siya mako-convert into energy? Ano mangyari sa kinain namin? Maiipon lang sa katawan mo in the form of adipose tissue. And that leads to the weight gain. Kaya yung mga taong may hypothyroidism, kapag mababa ang levels ng thyroid hormone mo, yung pagkain may ipon, makakadagdag sa timbang mo. Kaya tendency people with hypothyroidism, they tend to be obese, they tend to be overweight. Kasi kahit gaano kakonti ang kinakain mong pagkain, kung wala naman thyroid hormone na magko-convert ng food na yun into energy, di mo rin magagamit yun. May ipon lang yun sa body mo in the form of adipose tissue, which adds up to the weight. Okay? Kaya isa sa mga tinitingnan ng doctor, no, minsan kapag medyo duda yung doctor, no, especially when it comes to your obesity or yung overweight na status mo, minsan pinapacheck yung thyroid profile. Okay, minsan pinapacheck si thyroid profile para lang ma-rule out, no, na thyroid hormone yung cause ng pag-increase ng timbang, yung pag-increase ng glucose, ganyan. Okay, para lang ma-eliminate or ma-rule out yung thyroid hormones as a cause of a possible na weight gain, ganyan, ganyan. Okay, pinapacheck ni doctor yung thyroid profile. Okay, so minsan, ang may kasalanan kung bakit ka nadadagdagan ng timbang, minsan hindi naman ikaw eh, minsan hindi naman yung discipline mo. Okay, minsan yung hormone mo talaga ang may kasalanan. Okay, therefore, i-check nyo ha, baka mamaya isang dekada na kayong nagda-diet and parang hindi kayo nababawasan ng timbang. Eh baka naman hormones na ang issue mo. O baka naman problema na sa hormone. Yung tipong na-try mo na lahat ng diet, nag-Mediterranean diet ka na, nag-paleo diet ka na, kung ano ng diet na ang tinry mo, lahat na ng diet na try mo na, and yet, wala pa rin, eh baka naman hormones na ang may problema. Aside from hypothyroidism, another case or another possible cause ay PCOS. Okay, marami ngayon mga babae na diagnosed for having PCOS. So technically speaking, isa sa mga side effect ng PCOS, polycystic ovarian syndrome, is that nagkakaroon ng weight gain. Okay, side effect yon ng PCOS. Kaya may mga tao na minsan kahit na anong diet ang gawin nila, tendencies hindi sila bawasan ng timbang. Minsan hormones ang issue. Therefore, don't be so judgmental ha. Hindi lahat ng taong mataba ay mataba dahil gusto nilang maging mataba. Okay, so technically speaking, may iba na nadadagdagan ng timbang dahil saan? Dahil sa hormonal issues. Okay, minsan thyroid hormone, minsan mga sex hormones ang problema. Okay, pero either way, going back to the main issue, kung isa ka namang normal na nilalang, na wala namang hormonal imbalance, proper diet and exercise will still be the key in order for you to properly lose weight. Okay, pero either way, going back to the main issue, ang layo na narating ng story ko. Pero pag nagawa ni insulin, lahat ng yan, at the end of the story, ano mangyayari? Sa glucose levels natin, syempre, babalik na ang lahat sa normal. Okay, eventually, babalik ang glucose mo into normal. However, the question is, how long will that take? From the moment na kinain mo si pagkain hanggang sa bumalik yung glucose mo sa normal, usually gaano katagal? Yan. How long does it take from the moment you ate the burger hanggang sa bumalik yung glucose mo into normal? Usually it will take around 2 hours. And that is now the reason behind the 2 hours postprandial blood glucose. Di ba meron tayong test known as the 2 hours postprandial blood glucose? Ano ibig sabihin pag sinabing 2 hours postprandial blood glucose? 2 hours postprandial blood glucose, postprandial after eating. 2 hours after eating. Glucose levels mo, 2 hours after eating. Ang tanong, bakit 2 hours? Bakit hindi 3 hours? Bakit hindi 5 hours? Bakit kailangan 2 hours? Kasi kung isang normal na nilalang ka, dapat 2 hours after mong kumain, dapat yung glucose mo ay bumalik sa normal. Your glucose should return back to normal 2 hours after eating. Okay, so 2 hours after eating. So therefore, kapag 2 hours na nakalipas, di man lang bumalik sa normal yung glucose mo, there might be something wrong. Okay, there might be something wrong. Okay, so therefore, yun yung rationale no, behind the 2 hours postprandial blood glucose. And yan din yung reason kung bakit yung OGTT natin, no? 2 hours. Okay, yung maximum sa OGTT natin kadalasan 2 hours. Kasi normally 2 hours after natin kumain, dapat your glucose should return back to normal. Okay? So therefore, yan yung normal. Normal na process no going on inside the body from the moment you ate the food hanggang sa bumalik sa normal yung glucose natin. Okay? So ma'am, paano namin malalaman kung gumagana ba talaga yung mga yan inside the body? Paano ko malalaman kung nagtatrabaho ba yung pancreas ko, ma'am? Paano ko malalaman kung nadadigest ko bang maigi yung food na kinakain ko? So syempre, titingnan natin kung gaano kataas yung glucose mo in the blood. We will then have to measure the blood glucose natin. Kasi kung mataas yung glucose mo, that means there's something wrong with the process. Kung mataas ang glucose mo, that means there is something wrong with the process. Okay, so therefore, if that's the case, kailangan natin mag-analyze ng glucose. Syempre, bago tayo makapag-analyze ng glucose, ano munang kailangan natin? Kailangan natin ng specimen. Okay, kaya naman nandiyan sa notes natin yung mga details ng specimen collection. Okay, details ng specimen collection. Maraming pwedeng specimen for glucose ha. Pwede tayong mag-detect ng glucose sa whole blood. Pwede kang mag-detect ng glucose sa serum, sa plasma, even sa CSF, even sa serous fluid, si peritoneal, pericardial, pleural fluid, synovial fluid, at nagde-detect din nga tayo ng glucose sa urine, di ba? Maraming pwedeng specimen for glucose analysis. Pero, recall question, ano daw pala yung standard clinical specimen? If you really want to know if the glucose is well regulated inside your body, ang magandang specimen pala ay fasting venous plasma. Uy, ingat kayo ha, hindi pala serum. Serum yung most common. Pero iba ang most common sa most preferred. Ang mas preferred pala natin ay plasma. Venous plasma. Fasting venous plasma. Okay, chap-chapin natin. Fasting, usually kasi kapag glucose, this would require at least around 8 to 10 hours of overnight fasting. Okay, so fasting blood glucose, no? At least 8 to 10 hours daw dapat of overnight fasting. Okay, 8 to 10 hours of overnight fasting. Okay, 8 to 10 hours of overnight fasting. Ma'am, ang tanong, bakit overnight? Hindi ba pwedeng overday? Ma'am, for example, ma'am, nag-fasting naman ako, ma'am, during the day. Pumunta ako sa laboratory, hapon na, ma'am. Pero kumpleto ko naman, ma'am, yung 8 to 10 hours of fasting. Theoretically speaking, are we supposed to receive that patient? Should we receive that patient? Well, theoretically, practically kasi, oo, tatanggapin natin. Sayang, no? Kita ng laboratory yan, earnings din yan. Pero theoretically, we're not supposed to accept them. Ma'am, why? Kasi ganito yan. Ang glucose kasi Una is affected by a lot of things. Ano na ba yung mga nakakaapekto sa glucose natin? Una, ang glucose is affected by physical activities. Okay? Every move that we make, okay, kadalasan nagko-consume yan ng glucose. Okay? Every move that we make, everything that we do, everything that stresses us out, technically nakakaapekto yan sa glucose natin. Okay? Hindi lang physical activities, pati mental activities, pati brain natin pwede makaapekto sa glucose. Alam niyo ba na 25% ng glucose is consumed by the brain? 25 by the brain. So isipin mo na lang, kada cup ng rice. Kada cup ng rice na kinakain natin, 1/4 nun goes straight to your brain. Ganon katakaw ang brain natin when it comes to the glucose. Okay? Glucose, 25% no, is already consumed by the brain. Kaya pansinin nyo, kapag masyadong mataas, masyadong mababa ang glucose, ano agad yung una mong nararanasan? Nahihilo ka. Affected agad yung brain natin eh. Pag sobrang taas, sobrang baba ng glucose natin. And be careful kasi ang signs and symptoms ng mataas at mababang glucose ay parehas. Parehas kadalasan yung signs and symptoms ng mababang glucose at mataas na glucose. Okay, parehas nahihilo, parehas binabertigo, parehas hinihimatay. Kaya ingat, especially sa ER, sa emergency room. Minsan kasi may mga diabetic na pasyente, sinusugod sa ER, ang history e diabetes, yun pala, ang case ngayon na naging mababa yung glucose. Okay, na-overdose pala ng insulin, na-overdose pala sa gamot, sa metformin, tendency, excessively naging mababa yung glucose. So ingat kayo, hindi lahat ng diabetic na sinusugod sa emergency room ay nagko-complain of hyperglycemia ha. Minsan ang case pala nila ay hypoglycemia. Okay, pero either way, physical activities, mental activities can affect the glucose natin. Kaya hindi maganda yung alin, kaya mas advisable yung morning morning na specimen. Kasi at least after overnight na fasting, sa gabi wala kang masyadong ginagawa, medyo pahinga ang brain cells mo during the gabi, tendency is less ang physical and mental activities natin sa gabi, therefore hindi masyadong affected ang glucose natin. And finally, another important thing that affects your glucose, hormones. Hormones, they can affect the glucose natin. Best example ng hormone that can drastically affect the glucose ay si cortisol. Cortisol, famous for being the stress hormone. Kaya naman, kapag nai-stress ang isang tao, pwedeng tumaas ang glucose niya. Ang mga taong palaging nai-stress, pwedeng tumaas ang glucose nila. Bakit daw pala? Dahil sa cortisol. Yan, okay, dahil daw yan sa cortisol. Ma'am, anong kinalaman ng cortisol sa pangyayari? Ano ba kasi yan si cortisol, ma'am? Cortisol kasi, laging tatandaan, is the major glucocorticoid. Anong ibig sabihin pag sinabing major glucocorticoid? Chop-chopin natin. Gluco kasi they can increase the blood glucose levels. Cortisol kasi can increase the blood glucose levels. Corti, bakit siya tinawag na corti, ma'am? Kasi they are produced by the cortex of the adrenal glands. They are produced by the adrenal cortex. So, gluco, corti, oid. Ano yung nasa dulo? Oid. Bakit siya tinawag na oid? Kasi steroid hormone to. This is what you would call a steroid na hormone. Pag sinabi nga palang steroid hormone, cholesterol-based na hormone. Yan. Okay, kaya pala siya tinawag na major glucocorticoid. Gluco kasi they can increase the blood glucose levels. Corti kasi they're produced by the adrenal cortex. And oid kasi steroid or cholesterol-based kasi siya na hormone. Pero looking at it, ang cortisol pala natin ay glucocorticoid. Gluco, they can increase the blood glucose levels. Di ba ang cortisol natin, they're famous for exhibiting the diurnal variation? They exhibit the diurnal variation, which brings us to the recall question. Ang cortisol natin, kailan yan mataas? They are higher in the morning. Around 6 to 8 in the morning, mataas ang cortisol natin. At mababa sila pagdating na hapon. Iba ang levels nila sa umaga compared sa levels nila sa hapon. Okay, therefore, makakaapekto ba yung overnight fasting natin? Well, ito yung reason kung bakit ang glucose, mas maganda siyang kolektahin in the morning. Kolektahin in the morning para standardize ang lahat. Okay, standardize ang lahat. Furthermore, yung normal value kasi natin. Yung normal value natin for the FBS, applicable lang yon sa morning na sample. It would not really be advisable to use that in an afternoon na specimen. Okay? So bottom line, yan pala yung reason or yan pala yung mga reason kung bakit mas maganda yung overnight fasting. 8 to 10 hours of overnight na fasting. Okay, kasi mas maganda kung umaga magko-collect ng glucose after overnight fasting kasi glucose is affected by a lot of things. They're affected by physical activities, mental activities, and even with the activity of the hormones in your body, pwedeng makaapekto sa glucose. Okay? So therefore, kailangan daw at least 8 to 10 hours of overnight na fasting. Hindi rin naman advisable ang overfast. Kasi kapag overfasted ka na, tendency naman, no, especially kapag 16 hours mahigit na yung fasting mo, hindi rin advisable, no, kapag masyadong matagal yung fasting. Kasi ang tendency naman, bine-breakdown na ng katawan mo yung glycogen. Okay, kapag overfasted ang isang individual, tendency is bine-breakdown na nung katawan mo si glycogen. Eh di ba pag chinap-chop mo si glycogen, polysaccharide, anong lalabas? Lalabas si glucose. Pwedeng magmukhang mataas yung glucose mo. Yung pala, resulta yon ng pagbe-breakdown ng katawan mo sa glycogen. Okay, kaya naman usually at least mga 8 to 10 hours of fasting will suffice. Anything beyond that can lead to rather an overfasting. Possible na ma-overfast si pasyente. Pwedeng tumaas yung glucose niya, no? Kasi the glycogen has been broken down. Pwedeng ma-release yun into the bloodstream in the form of glucose. Okay? So as much as possible, hindi advisable yung lalagpas ng 14 hours particularly. Kadalasan pag 14 hours, get overfasted na kadalasan ang isang individual. Especially when we're talking about the glucose. So sufficient naman na yung mga 8 to 10 hours, no, of fasting particularly for the glucose analysis. Okay? Pero either way, by the book yan ha, yung 8 to 10 hours ng fasting natin. Okay? Pero either way, that is for the fasting. Pero ma'am, bakit Venus? Bakit Venus? By the way, recall question to mga naka-underline na to ha. Venus blood ay may mas mababa. Mas mababa ang glucose ng venous blood kesa sa arterial blood. Eh bakit siya yung preferred natin, ma'am? Venous blood daw pala has lower glucose. Eh why do we prefer the venous blood? Why? Why do we prefer the venous blood? Well, simple lang. It's easier to collect eh. It's easier to collect the venous blood than the arterial blood. At saka ang mga medtechs, what we are allowed to do is only the venipuncture and the skin puncture. Ang allowed lang tayo ay, theoretically ha, ang allowed lang tayo ay mag-perform ng venipuncture. Pag venipuncture kasi ang makukuha mo dyan ay venous blood. Kapag skin puncture naman na makukuha mo ay capillary blood. Medtechs are only allowed to do venipuncture and skin puncture. We are theoretically not allowed to do the arterial puncture. Okay? So therefore, ang reason lang naman kung bakit venous blood yung mas preferred natin kasi mas madali siyang kolektahin. At yun lang din naman ang allowed tayo mga medtechs to do. Well, theoretically speaking. I know for sure there are a lot of medtechs and even interns, no, that are very brave enough to do an arterial na puncture. Pero again, theoretically, we're not supposed to do that. Okay? So, preferred natin si venous blood. Ang reason lang naman, it's easier to collect it. And siya lang din naman ang advisable for us to perform or to collect. Okay? We're not really allowed to do the arterial puncture theoretically speaking. Okay? At saka imagine niyo na lang, no? What if OGTT yung request? Tapos puro arterial blood, no? Ang gagawin mo. Imagine life. OGTT. May fasting. May 30 minutes, may 60 minutes, may 120 minutes. Minsan may 90 minutes pa nga in between. Ang dami i-collect sa'yo. Mga nasa 3 to 5 ang specimen eh kapag oral glucose tolerance. Imagine kung puro arterial puncture yun, no? Baka paslangin ka na ng pasyente mo, pinahirapan mo si pasyente. So, yun yung reason kung bakit hindi talaga advisable ang arterial puncture kasi mahirap siya. Or rather, medyo mahirap siyang gawin lalo kapag multiple collections yung gagawin natin, such as in the case of the oral glucose tolerance test natin. So therefore, venous ang preferred natin kasi it's easier to collect the venous than the arterial blood. Okay? Eh ma'am, ba't di natin ginagamit si whole blood? Bakit plasma ang preferred natin? Ang whole blood, pwede mo naman tong gamitin. Yun nga lang, be careful, recall question. Whole blood gives approximately 10 to 15% lower glucose levels compared to the plasma or the serum. Ingat ha, recall question yan 10 to 15%, pati lower. Nung tinanong kasi ito ng board exam, dalawa yung 10 to 15% sa choices. Isang lower, isang higher. So ingat, whole blood mas mababa ng 10 to 15% compared to that of the serum or plasma. Now, ito ngayon yung reason kung bakit never ever compare the results of glucometer sa results ng laboratory. Wag niyo i-compare yung result ng mga glucometer sa result ng laboratory. Ma'am, bakit? This is one of the common mistakes ng mga pasyente. Minsan may mga pasyente na nagagalit. Okay, naalala ko there was a time during internship namin, no? May nag-aamok na pasyente sa labas. Galit na galit si pasyente. Ang sabi ni pasyente, so syempre ni pasyente, bakit daw ganun yung result niya sa laboratory? Ang taas daw ng glucose niya sa laboratory. Samantalang araw-araw naman daw siyang nag-glucometer. Araw-araw naman daw siya nag-glucometer. Normal naman daw yung glucose niya sa glucometer. Sabi pa nga, no, pineperahan nyo lang ba yung mga pasyente nyo? Ayan, galit na galit si pasyente. No? Pineperahan nyo lang ba yung mga pasyente nyo? Ginagawa nyo mataas yung glucose kahit normal naman yung glucose, ganyan-ganyan. So, ano nga bang reason? Bakit normal siya sa glucometer? Bakit pagdating sa laboratory, mataas na pala yung result niya? Kasi sa glucometer, finger prick, capillary, whole blood yung makukuha mo doon. Ano bang characteristic ng whole blood natin? Mas mababa siya ng 10 to 15%. Okay, kaya naman, ito rin yung reason kung bakit yung mga doctors, kahit sabihin mong nag-glucometer ka araw-araw, sasabihin pa rin ni doctor, magpaparequest pa rin siya ng lab test. Bakit nga ba ganun, no? Araw-araw ka naman nag-glucometer, pinakita mo yung ano mo, yung listahan mo, araw-araw ka nagpapa-check nagche-check ng glucose mo sa glucometer, pero magpapa-request pa rin si doktor ng FBS sa laboratory. Okay, bakit ganon? Kasi minsan si doktor walang tiwala. Walang tiwala, hindi sa glucometer. Sa pasyente siya walang tiwala. Okay, ma'am, bakit sa pasyente siya walang tiwala? Minsan kasi hindi tama yung paggamit nila ng glucometer. Hindi tama yung paggamit ng glucometer. Ano kasi nangyari? Minsan hindi pala buo yung blood na nakalagay sa strip. Minsan kalahati lang ng strip yung may dugo. Kaya pala mukha siyang normal kasi kalahati lang ng strip yung may laman na dugo. Okay, so although wala namang issue si doctor dun sa mismong device, minsan ang nagiging issue ni doctor is yung gumagamit rather ng device. Okay, kasi kahit gaano ka-accurate yung device po, kung hindi naman tama yung pagpe-perform or paggamit ng glucometer, magiging erroneous pa rin yung result. Okay, kaya naman, despite the idea that we have the glucometers already, sometimes the doctor will still push the request of an FBS, ano, okay. Kasi kumbaga mas may tiwala siya sa mga medtechs, no, compared sa mga mismong pasyente. Pero again, recall question ha, never ever compare the results of the glucometer with the results of the laboratory. Kasi iba ang nagiging glucose level sa whole blood compared to the serum or the plasma. Okay, ma'am, hindi na maganda si whole blood, mas preferred natin si serum or mas preferred natin si plasma? Bakit di natin preferred yung serum? Actually, pwede mo naman gamitin si serum, which is done in the laboratory, especially kung na-separate mo naman siya from the cells within 30 to 60 minutes, which is nagagawa naman natin normally sa laboratory, di ba? Pag nakapag-collect tayo ng dugo sa laboratory, sinecentrifuge naman natin agad yung dugo We usually manage to separate the serum from the cells, the serum from the clot within 30 to 60 minutes. That's why okay lang naman gumamit ng serum. Pero syempre, iba yung most common sa most preferred. Ang most preferred talaga natin ay plasma, especially collected using the gray top. Gray top. Ano nga ba ang laman ng gray top natin? Gray top tubes would contain your sodium fluoride. And sodium fluoride, recall question, ginagamit siya to prevent glycolysis. Anti-glycolytic agent, it prevents glycolysis. However, recall question, if you're planning to use it as an anti-glycolytic agent, ano dapat ang concentration ng sodium fluoride na gagamitin natin? If you're planning to use it as an anti-glycolytic agent, you have to use it at a 2 milligram na concentration. Pero ingat, there was also a time in the board exam na ang tanong ay hindi anti-glycolytic agent. Ang tanong ay anticoagulant. So, ingat sa tanong Pareha silang may anti sa unahan, kaya mag-iingat kayo. If you're planning to use sodium fluoride as an anticoagulant, ang problema, sodium fluoride is a weak. It's a very weak anticoagulant. So if you're planning to use it as an anticoagulant, you would need to use it at a higher concentration. You would need to use it, according to the Book of Thieats, you have to use it at 3 to 5 times higher na concentration. So that means if you're planning to use it as an anticoagulant, you will have to use around 6 to 10 milligrams ng sodium fluoride for every ml of the whole blood. Okay, so 6 to 10 milligrams. Nung nag-appear yan dati ng board exam, 10 milligrams yung nag-appear sa choices. Okay, so 6 to 10 milligrams, yan yung 3 to 5 times higher na concentration natin. 6 to 10 milligrams na sodium fluoride, again, if you're planning to use it as an anticoagulant. Okay, parehas recall question yan ha, so be careful with the anti-glycolytic agent and anticoagulant. Pero teka, ano bang action ng sodium fluoride? How can we say that it can prevent glycolysis? Ano bang action ng sodium fluoride? Sodium fluoride actually targets your magnesium. Ang target talaga niya ay si magnesium. Kasi pag nawala si magnesium, hindi nagagana si enolase. And enolase is one of the rate-limiting steps sa glycolysis natin. Isa yan sa mga importanteng enzyme sa glycolysis. So therefore, pag nawala si magnesium, pag na-inhibit si magnesium, may inhibit na rin si enolase. Mai-inhibit na rin si enolase. Eh syempre, pag nawala si enolase, hindi nagagana si glycolysis, mai-inhibit na si glycolysis. Therefore, we would be able to prevent the glycolysis simply by using the sodium fluoride. Okay, so therefore, indirect na yung action niya sa glycolysis natin. Okay? Ma'am, gaano ba ka-importanteng i-prevent si glycolysis? Importante ba talaga, ma'am, na i-prevent si glycolysis? Yes, kasi si glucose. Pag iniwan mo kasi yan at room temperature, glucose is metabolized at a rate, recall question to, of 7 milligrams per deciliter per hour. Biruin mo, isang oras mo lang maiwan sa room temperature, 7 agad ang mababawas. Malaking deal ba yun? Is that a big deal? Yes, definitely. 7 agad, oh, isang oras lang. Isang oras mo lang maiwan yung specimen mo. Sa room temp, 7 na agad ang makakaltas, 7 na agad ang mababawas. So therefore, importante talaga na nagpe-prevent tayo ng glycolysis. Kahit ilagay mo siya sa ref, kahit ilagay mo siya sa refrigerated temperature, nababawasan pa rin ang glucose ha. It is metabolized at a slower rate, 2 milligrams per deciliter per hour. Bottom line, nababawasan pa rin. Lagay mo sa room temp, mabawasan. Lagay mo sa ref, mababawasan pa rin. So therefore, how do we prevent yung pagbaba ng glucose sa specimen natin? Mas maganda i-prevent mo yung glycolysis. And that is by adding the sodium fluoride. Okay? Recall question tong rate ha. Rate ng metabolism both at room temperature and at refrigerated temperature. Okay? Aside from this, nagde-detect din tayo ng glucose sa CSF. And in your notes, meron tayong dalawang importanteng recall question when it comes to the CSF glucose. If you were to compare the glucose daw, in the CSF and the plasma, ang CSF glucose pala natin ha is approximately 60 to 70% lang compared to the plasma concentration. Uy, ingat kayo ha, ang CSF glucose, 60 to 70%. Apparently, there's another recall question, no? CSF protein. If you were to compare CSF protein naman, ingat kayo, if you were to compare CSF protein with that of the plasma concentration, ilang percent pala ang CSF protein natin compared to the plasma protein natin. Ingat kayo ha, ibang usapan ang protein sa glucose. Ang glucose, 60 to 70% siya. Pero ang CSF protein, this is just less than 1%. Less than 1% lang siya, that of the plasma concentration. Mag-iingat kayo sa tanong ha, parehas na kasi silang tinanong dati ng exam eh. CSF glucose is 60 to 70%, ang CSF protein natin ay less than 1%. Okay, so mag-iingat kayo. Ito ngayon yung reason kung bakit kapag may request na glucose for the CSF, may kasabay yan. May kasama yan kapartner na blood glucose. Kasi kailangan ma-compare eh. Kailangan ma-check natin kung yung glucose ba sa CSF ay 60 to 70% talaga compared to the plasma glucose or the blood glucose level. Kaya naman, kapag may CSF na specimen for glucose, dapat may kapartner yan na blood glucose. And sino nga pala mauunang kolektahin? Usually, the blood glucose is obtained first, and then after 1 to 2 hours, magpe-perform na si doctor ng lumbar puncture or what we would call the spinal tap. Okay? Mauuna si venipuncture, and then maghihintay ng 1 to 2 hours bago mag-perform ng spinal tap or lumbar puncture. Bakit may 1 to 2 hours na interval? It is actually to allow equilibrium. To allow equilibrium para magbalanse. Okay? Ang blood glucose ang mauuna, tapos may 1 to 2 hour na interval bago yung spinal tap or lumbar puncture. Okay, ma'am, the purpose of the interval is to allow equilibrium. Pero bakit mauuna yung glucose sa blood bago mag-collect? Bakit kailangan mauna yung venipuncture bago yung lumbar puncture? Can it be the other way around? Hindi ba pwedeng lumbar puncture muna, ma'am, tapos maghintay ako ng 1 to 2 hours bago yung venipuncture? Bakit kailangan mauna si venipuncture? Well, simply lang naman ang reason, you just have to break it to the patient gently. Break it to the patient gently. Usually, mag-start tayo sa less complicated procedure before sending them off to the more complicated na procedure. Always break it to the patient gently. Start ka muna sa simpleng procedure bago ka magpunta sa mga invasive na procedure. Kasi pag nauna yung invasive na procedure at na-trauma yung pasyente mo, sa tingin mo ba makikita mo pa yung pasyente mo? Well, mataas ang chance na ni anino ng pasyente mo, di mo na makikita. Tinataguan ka na ni pasyente. Especially pag na-trauma si pasyente, no? Ay, mataas ang chance na tataguan ka na ng pasyente. Okay. After all, maraming tao ang takot magpa-ospital. Maraming tao na takot magpa-laboratory, no? Okay. Kasi tingin nila sa ating mga medtech, palagi tayo nangunguha ng dugo. Okay. So, technically speaking, may mga tao na takot pakuha ng dugo. So, yung iba, pag na-traumatize sa isang procedure, sometimes no, they're not going back anymore. Di na sila bumaba like for the other procedures. So, again, you have to break it to the patient gently. Always start with the less complicated procedure before moving them to a more invasive na procedure. Okay? So, yun lang naman yung rationale as to why venipuncture should go first. Pero importante yung 1 to 2 hours na interval, ha? Para magkaroon ng equilibrium before collecting for the CSF na glucose. Okay? So, yun lang naman so far with the important specimen concerns natin, especially when it comes to the glucose analysis. Pero either way, now that we have the specimen, we can now begin the analysis. And in your notes, we have in there the different methods for glucose analysis. And we can split them out into two categories. Meron tayong mga sinaunang chemical methods at meron tayong mga makabagong enzymatic methods. Ma'am, do we really have to know the old methods? Well, unfortunately, yes. Kasi kahit luma na itong mga methods na to, tinatanong pa rin siya pagdating sa board exam. Although karamihan dito bihira nang gamitin, pero tinatanong pa rin sila sa exam. Let's try to start first with the chemical methods. Okay, before we go to the enzymatic na methods. Okay, so in this case, we have the chemical methods. We have the copper reduction. We also have the ferric reduction. And we also have the condensation method. Start tayo with the copper reduction. Copper reduction. Ganito yan. Di ba may dalawang klaseng copper tayo? Meron tayong tinatawag na copper 2 plus, which is the cupric, at meron tayong copper 1 plus, which is the cuprous. Okay? Di ba nabanggit natin na most of your carbohydrates are reducing sugars, especially glucose. Glucose is one of the examples of your reducing sugar. Okay? Meaning, it is a sugar that is capable of doing reduction. Pag sinabing reduction, pagbabawas. Reduction, reduce, bawasan. In short, ang glucose natin, being a reducing sugar, a reducing substance, they can reduce the oxidation state of your copper. Meaning, kaya nilang bawasan yan. 2 plus na yan, kaya nila i-convert yan into 1 plus. Okay, so yun yung ibig sabihin ng reduction. Pagbabawas. From 2 plus, kaya nila i-convert yan into 1 plus. Okay? However, because of this particular equation, there are two important things that we have to note of. Okay? Important thing number one. Is your copper reduction specific for the glucose? Specific ba ang copper reduction test natin for the glucose? The answer is no. Copper reduction is not specific for the glucose. Bakit? Kasi they can actually detect the reducing sugars. Okay, sino-sino ba kasi ang mga reducing sugar? Lahat lang naman, except for one. Most of your carbohydrates are reducing sugars except for your sucrose, which brings us to the second point. Sino pala yung sugar that is not detected by the copper reduction? Not detected by copper reduction is yung non-reducing sugar natin. Sino ba yung non-reducing sugar natin? Yung ating sucrose. Okay, sucrose is not detected by copper reduction kasi remember, sucrose is a non-reducing sugar. Okay, non-reducing sugar kasi. So therefore, it won't be detected now by the copper reduction natin. Okay, so therefore, laging tatandaan ha, okay, laging tatandaan na ang copper reduction natin, again, they're not really specific. Hindi sila specific for the glucose. Okay? Kasi nadedetect nila lahat ng reducing sugar. Sino lang ba ang hindi nila nadedetect? Ang di lang nila nadedetect is yung non-reducing sugar, which happens to be your sucrose. Okay? So therefore, yun yung reason kung bakit medyo bihira na lang gamitin si copper reduction. At minsan kung gagamitin natin yan, kadalasan sa urine na lang yan ginagamit eh. Most of the time, sa urine na lang ginagamit etong si copper reduction. Okay? Pero either way, ma'am, anong connect nito sa glucose? Paano namin malalaman, ma'am, kung gaano kadami yung glucose? Laging tatandaan, kapag maraming glucose, maraming cupric ang mako-convert into cuprous. So therefore, how would we know kung maraming glucose? Maraming glucose kapag marami kang na-measure na cuprous. Okay, lagi tatandaan ha. Sa copper reduction, pag maraming glucose na present, maraming cupric ang magiging cuprous. So therefore, paano natin malalaman kung maraming glucose or maraming reducing sugar? Magme-measure tayo na cuprous. Which now leads us to the second important thing. How do we measure the cuprous? Paano natin mini-measure si cuprous? Laging tatandaan, etong process na to is just the beginning. This is just your step number 1. Kailangan pa nating i-quantify to. Kailangan pa nating i-quantify si cuprous kasi malalaman lang natin kung maraming glucose kapag maraming cuprous. So now the big question is, how do we measure the cuprous? Kung step 1 lang to, sinong pwede nating idugtong na step number 2? Doon ngayon papasok yung mga methods na nandyan sa notes natin. We can make use of the Nelson-Samoggy. We can also make use of the Fallen-Wu. At pwede rin tayong gumamit ng neocuproin or neocuprine na method. Laging tatandaan, recall question. Yang tatlong yan, they're all based on copper reduction. Yang tatlong yan ay pare-parehas copper reduction. Ano lang ang differences nila, ma'am? Magkakaparehas lang pala yan. Pare-parehas lang copper reduction ng principle ni Nelson-Samoggy, ni Fallen-Wu at ni neocuproin. Ang difference lang nila ay yung reagent at yung syempre itsura ng positive result. Si Nelson-Samoggy, I think nandiyan na sa notes natin, ang reagent niyan ay si arsenomolybdate at ang positive result is formation of the arsenomolybdenum blue or simply blue as the positive result. Si Fallen-Wu naman, I think nandiyan naman na to sa notes natin, no? So, hindi nyo na kailangan kopyahin. Ang reagent natin dyan ay si phospholipase at ang positive result is the formation of the phospholipdenum blue or simply blue as the positive color. And finally, copper reduction din pala to. Sineocuprine or sineocuproin na method. And syempre, tinawag siyang neocuproin kasi ang reagent mo rito ay sineocuproin. Positive result, yellow to yellow-orange the color. So, siya lang ang naiiba, no? Parehas blue yung positive result. Sa Fallen-Wu at sa Nelson-Samoggy, ang naiiba lang ay si neocuproin na method. Okay, pero again, they're all based on copper reduction. And again, it's all based on the idea that most of your carbohydrates are reducing sugar. They can convert cupric into cuprous, and you can use that no, as a principle to detect the reducing sugars natin. Yun nga lang, don't forget the important notes ha. Hindi siya specific for the glucose at hindi niya madedetect yung ating sucrose. Okay? Now, si copper reduction is somehow similar to the ferric reduction. Okay? So, natin si ferric reduction. Uy, ferric reduction. Nandiyan ba yung lumang pangalan ni ferric reduction? Ferric reduction is otherwise known as the Hagedorn-Jensen reaction. Hagedorn-Jensen or Hagedorn-Jensen, bahala na kayo kung paano siya ipopronounce. Hagedorn or Hagedorn-Jensen reaction, the old name for the ferric reduction. And actually, concept-wise, kamukha lang nito si copper reduction. Yun nga lang, instead of using copper, we will now be using iron. Di ba may dalawang klase tayo ng iron? Si ferric or Fe3+, at si ferrous, Fe2+. And remember, most of your carbohydrates, including glucose, they are reducing sugars, meaning they're capable of doing reduction. Meaning, they can reduce. Kaya nilang bawasan si ferric. Kaya nila i-convert yan into ferrous. Okay, they can convert the ferric into the ferrous. Again, reduction pa rin ha. Pagbabawas pa rin, si 3+, mako-convert into 2+. Okay, so that's why we call it the ferric reduction. However, reduction pa rin yan, meaning applicable pa rin yung dalawang notes natin kanina. Ano yung dalawang note natin kanina sa copper reduction? Kagaya lang sa ferric reduction. Ferric reduction is not specific also for the glucose. Hindi siya specific for glucose. Bakit? Kasi they can also detect the reducing sugars. Hindi lang naman kasi si glucose ang reducing sugar ha, which means to say, sino lang yung sugar that is not detected? Not detected by ferric reduction, it would also be your sucrose. Okay, kasi remember, sucrose is a non-reducing sugar. So yung dalawang notes natin kanina, dun sa ating copper reduction, applicable din pala sa ferric reduction natin. Okay, applicable din yan sa ferric reduction natin kasi pares lang naman silang reduction Ang difference lang is kung sinong element ang ginamit natin. Kanina we used the copper, now we're using your iron. Pero meron pang isa pang point of difference. Aside from using copper kanina, tas iron ngayon, another point of difference is that ferric reduction is based on what we call an inverse colorimetry. Ano yung ibig sabihin ng inverse colorimetry? Ito yan. Inverse colorimetry, kabaliktaran ng colorimetry. Kadalasan kasi pag colorimetry, we are looking for the appearance of a color. Kapag colorimetry kasi, we're looking for the appearance of the color. Pero kapag inverse colorimetry, it's just the opposite. You are looking this time for the disappearance of the color. Ganun pala si ferric reduction. Ang inaabangan mo rito ay pagkawala ng kulay. Ang ferric kasi, they're originally yellow in color. Ang ferric, yellow siya in color. Pero pag na-convert na yan into ferrous, mawawala yung pagiging dilaw, magiging colorless na siya. Kaya naman, ang ferric reduction, isa pa palang point ng difference siya sa copper reduction, no? Ang copper reduction kasi, colorimetry, appearance ng kulay ang inaabangan natin, appearance ng blue, appearance ng yellow to yellow-orange color, colorimetry kanina si copper reduction. Pero this time, si ferric reduction, inverse colorimetry. We are looking for the disappearance of the color. Okay? However, the most important part of it all is yung last item natin sa chemical na test natin. Last item on the chemical test, we have the condensation method. Pero I think na-mention na natin yung tatlong recall question dito. Naalala niyo ba yung tatlong recall question sa condensation method? Number 1, di ba yung other name niya ay Dubowski? At para saan na nga daw si Dubowski? Recall question number 1, Dubowski is a method for glucose analysis. Okay? And minsan sa ibang libro, tinatawag siyang orthotolwithin method because the main reagent ay si orthotolwithin. Okay? Orthotolwithin, dagdagan mo lang ng acetic acid, heat mo lang at 100 degrees centigrade, and maghihintay lang tayo ng appearance ng color. Which brings us to the second recall question. Ano na nga yung positive color sa Dubowski? Ano na nga yung positive color sa condensation method? Bluish green na color. And again, naalala niyo pa ba, pag pinapili tayo between blue and green, sino ang pipiliin natin? Green ang pipiliin natin. Sa lumang libro kasi, green lang ang nakalagay. And pangatlong recall question, ano na nga yung wavelength na ginagamit natin to measure the bluish green na color na yan? The bluish green color is measured spectrophotometrically 620 to 630 nanometers. That's why we have to use visible light source, di ba? For this one. Okay, mga nabanggit naman natin yan last time when we talked about the spectrophotometer natin. Okay, nasa bandang page 1 yan ng ating notes. Pero bottom line, Lubowski is a method also for glucose analysis. Okay? However, yung mga yan ay mga sinaunang methods na for the glucose analysis. We really don't use them much anymore. Kasi yung iba sa kanila ay time consuming. Okay, time consuming kasi karamihan sa kanila, kaya naman we rarely actually use them in real life na practice. Okay, usually ang ginagamit na natin ngayon ay mga enzymatic methods. Have you ever wondered why enzymes are used? Bakit nga pala enzyme ang ginagamit natin as reagent? Kasi enzymes are biocatalysts, pampabilis. So, para mabilis yung result natin, magandang gumamit ng enzyme. Kaya naman, a lot of automated instruments nowadays now are using enzymes as reagent kasi enzymes can make it quicker. Enzymes can make the reactions faster. Marami tayong enzymatic method pero may dalawang madalas na naglalaban. Glucose oxidase at saka hexokinase coupled with your G6PD. And recall question, sino na nga sa kanilang dalawa yung reference method natin? Reference method for glucose analysis. Ingat ha, reference method for glucose analysis is yung pangalawa, si hexokinase coupled with the G6PD. The question is why? Bakit nga pala si hexokinase coupled with G6PD? Bakit siya? Bakit siya ang reference method natin? Bakit hindi si glucose oxidase? Ma'am, mukhang specific naman si glucose oxidase Bakit hindi siya? Glucose oxidase is not the reference method because of two reasons. What are those reasons? Okay, una, kasi glucose oxidase is specific. Particularly, it is too specific. Masyadong OA yung specificity ni glucose oxidase. Ma'am, paano mo naman sabi masyadong OA ang specificity niya? Ang problema kasi kay glucose oxidase can detect one type of glucose only. They can detect the beta glucose only. Kasi ganito yan. May dalawang klase kasi ng glucose in the body. Meron tayong tinatawag na alpha glucose which accounts to 35% at meron tayong beta glucose which accounts to 65%. Meaning, kapag glucose oxidase ang ginamit mo, di hala, 65% lang ang madedetect mo. Would that be an accurate reflection of the total glucose that you have in the body? Unfortunately, no. 65% lang madedetect mo, lagpas ka lang ng kalahati. It will not really look at the overall glucose mo in the blood. Okay, kaya hindi masyadong advisable si glucose oxidase kasi masyado palang OA yung kanyang specificity. However, hindi na to issue kasi mag-a-add ka lang ng enzyme. Mag-a-add ka lang ng enzyme para ma-convert yung mga alpha glucose into beta glucose. Total, ang problema mo, beta glucose lang ang nadedetect, convert mo na lang yung 35%. Yung alpha na 35%, convert mo na lang into the beta glucose. And how are we supposed to do that? Well, you just have to add the enzyme. Add the enzyme mutaro. Okay, recall question to si mutarotaze lagay natin sa chat box. To convert the alpha glucose into beta glucose, mag-a-add ka lang daw ng mutarotaze. Okay, so yun lang pala yung gagawin natin para yung problema mo, yung malaking problema mo na alpha glucose na hindi na-detect, convert mo na lang into beta para alin? Para ma-detect na natin siya. So ma'am, hindi naman na pala problema yan. Bakit di pa rin siya? Bakit di pa rin siya ang reference method? Dahil sa pangalawang reason. Ano ba yung pangalawang reason? Kasi, pangalawang reason, ang glucose oxidase kasi is affected by oxidizing agents and by reducing agents. Okay? Problema, si glucose oxidase pala affected by oxidizing agent and by reducing agent. Okay? Anong effect ng oxidizing agent sa glucose oxidase? Laging tatandaan, ang reagent mo, ganito ha. Okay, di ba? Ang reagent natin ay si glucose oxidase. Glucose oxidase, as the name suggests, oxidase, nagpo-promote yan ng oxidation. Hinaluan mo ng specimen, Tas yung specimen mo pala ay may oxidizing agent. Oxidizing agent, an agent that promotes oxidation. Pinaghalo mo sila, ano kayo mangyayari? Oxidation na dito, oxidation pa doon. Doble-doble yung oxidation na. Parehang 1 plus 1, magiging 2. They would add up with each other. Ano mangyari? They would add up with each other, causing a false increase or a false positive na result. Kasi oxidation na yung pinopromote ng reagent mo. Specimen mo, may oxidizing agent din na nagpo-promote ng oxidation. Oxidation na here, oxidation na there, oxidation everywhere. Ano mangyari? They would all add up with each other, causing an increase or a positive na result. So therefore, ano palang effect ng oxidizing agent sa glucose oxidase natin? It would cause a false increase or a false positive na test result. And sino yung best example? Best example ng mga oxidizing agent na pwedeng maligaw sa specimen natin. Best example ng oxidizing agent number 1, detergent. Pangalawa, rust or kalawang. Those are examples of oxidizing agent that may enter. Paano? Paano sila nakapasok sa specimen namin, ma'am? Well, baka naman yung test tube na ginamit may sabon-sabon pa sa loob. Uy, may sabon-sabon pa sa loob. Sino kaya may kasalanan? Bakit kaya may sabon-sabon sa loob yung test tube? Sino ba naghugas ng test tube? 'Di ba ang paghuhugas ng test tube ay isa sa mga job description ng intern. Si intern pala ang may kasalanan. Minsan kasi may mga may mga rotation sa laboratory that all the intern rather has to do ay maghugas ng test tube. Meron tayong dedicated means, may mga hospitals na may sariling rotation yung washing ng test tube. Yung tipong 1 week ka sa washing department, kala mo major department. 1 week ang gagawin ni intern ay maghugas ng test tube. Minsan si intern nauurat na, nai-stress na maghugas ng test tube. Magta-time out na. Nagmamadali na ngayon si intern maghugas ng test tube. Minadali ang paglilinis ng test tube. Minadali ang pagbabanlaw dun sa test tube. Kinabukasan, pag kinuha mo si test tube, may puti pa sa loob si test tube. May naiwan pang detergent sa loob. Ay, ang detergent, meron, or considered yan as a strong oxidizing agent. What if morning peak? Yung medtech staff nagmamadali, kumuha ng serum, kumuha ng urine, isinalin dun sa test tube. Ano nangyari sa serum sa urine mo? Congratulations, it's now contaminated with detergent. Ano mangyari sa result mo? False increase, false positive. Therefore, lesson for today, pagalitan ang mga intern na hindi ginagawa ang tamang trabaho. Uy, may reason na kayo para mang-demerit ng intern in the future. Okay, gumawa ng reason para mang-demerit ng intern. Okay, pagalitan ng mga intern na hindi inaayos ang paghugas ng test tube. Pero ipaliwanag nyo kung bakit nyo sila dinedemerit, ha? Minsan kasi may mga staff, no, na demerit lang, na demerit without a valid reason. Paliwanag nyo sa kanila kung gaano ka-importante yung paghuhugas ng test tube, that can greatly affect the results of your patient. Okay, so therefore, wag kakalimutan ha, yung mga examples ng oxidizing agent, detergent, at saka rust. Teka ma'am, okay, explainable yung detergent, pero ma'am, paano yung rust? Paano yung kalawang? Paano napunta yung kalawang ma'am sa specimen natin? Best example, reagent strip. 'Di ba minsan, I do hope hindi niyo na 'to ginagawa, pero dati nung time ko, may mga hospitals na naggugupit pa ng reagent strip. And I do hope hindi niyo na 'to ginagawa. Okay? Minsan, yung gunting na ginagamit, una, baka hindi malinis, baka may bacteria. Possible na ma-contaminate yung reagent strip mo with bacteria. And to make things worse, yung gunting na ginamit mo may kalawang. Kalawang is iron oxide. Kalawang is unoxidizing agent. What if yung gunting na may kalawang napunta doon sa glucose pad natin? Uy, di ba ang glucose pad ng urine reagent strip is based on double sequential enzymatic reaction? Ano na nga yung dalawang magkasunod na enzyme? Double sequential enzymatic reaction na ginagamit natin dun sa reagent strip. Ito rin yon, si glucose oxidase combined with peroxy days. Okay, ano mangyayari pag yung kalawang napunta dun sa glucose pad ng urine reagent strip, gumagamit ng glucose oxidase yun. Ano mangyayari? Oxidation kalawang, oxidation sa reagent strip, they will add up with each other. Ano mangyayari sa result mo? Tataas. yung result mo. Magfa-false positive, magfa-false increase. So, lesson for the day, wag na wag kayong magka-cut ng reagent strip. It's not really advisable to do that. 1:1 dapat yan. One strip for a single patient. Okay, theoretically speaking. Pero I know for sure there are still laboratories no, na nagugupit pa ng reagent strip. Okay, pero again, hindi talaga advisable. Okay, kasi yung gunting, possible na may kalawang, possible na may bacteria, makakaapekto yan sa analysis natin. Okay? Pero either way, yan yung mga examples no, ng mga oxidizing agent. At ano daw ang effect ng oxidizing agent sa glucose oxidase natin? False positive or false? Increase. Kaya again, ito yung isa sa mga reason kung bakit hindi talaga siya magamit as a reference method. Kaya hindi magamit na reference method si glucose oxidase kasi they can be affected by the presence of oxidizing substances. Okay? Last thing to remember, they're also affected by reducing agent. And this time, ano kayang effect ng reducing agent sa glucose oxidase natin? Remember, ang reagent mo ay glucose oxidase, nagpo-promote ng oxidation. Hinaluan mo ng specimen at ang specimen mo ay merong reducing agent, an agent that promotes reduction. What do you think would happen pag pinaghalo mo yan dalawang yan? Oxidation, reduction. Ano bang characteristic ng oxidation and reduction? They're polar opposites of each other. Polar opposite ni oxidation, si reduction. Kung lalagyan mo yan ng analogy, parang liwanag at dilim, mabuti at masama, angel, devil, aso't pusa. Ano mangyari pag pinaghalo mo yan? Mag-aaway yan. They will cancel out each other. Oxidation cancels out the reduction. The reduction will also cancel out the oxidation. Hala, wala ng oxidation. Wala ka ng reagent. Ano mangyari pag wala ka ng reagent? May madedetect ka ba pag wala ka ng reagent? Wala na. Ano mangyari sa result mo? Magpo-false decrease, magpo-false negative. Yung result mo, wala ka ng reagent na cancel out. Na-cancel out ni reduction yung reagent. So therefore, ano palang effect ng reducing agent? Ano palang effect ng reducing agents natin? They would cause false negative, false decrease. Which brings us to another important recall question. What are the best examples of your reducing agents? Ano pala yung mga examples ng reducing agent natin? Uy, favorite recall question yung una dyan. Ascorbic acid. Ascorbic acid or vitamin C is a very strong reducing na agent. Okay, reducing agent. Ang tanong, mapipigilan mo ba yung mga tao sa pag intake ng ascorbic acid? Can we stop people from taking up ascorbic acid? Can we? Pwede ba sabihin sa pasyente mo, uy, pwede bang wag ka muna mag-take ng ascorbic acid today? Glucose oxidase kasi yung method ko. Pakialam ba ni pasyente sa glucose oxidase na yun? You cannot stop people from taking up ascorbic acid. After all, may mga tao na lumalaklak talaga ng vitamins ng ascorbic acid. Especially yung pandemic, no? Nagkakaubusan kaya ng vitamin C dati, no? Pandemic. People are taking up massive doses of vitamin C. Pero okay lang ba yon? Okay lang ba mag-intake tayo ng vitamin C ng sobra? Wala bang overdose ng vitamin C? Well, fortunately for us all, wala namang overdose ng vitamin C. Kasi water-soluble kasi si vitamin C. Water-soluble kasi si vitamin C. In short, any excess that you take will be urinated. Iihi mo lang yung sobra. Okay? Iihi mo lang yung sobra. Hindi kasi siya nai-store sa body natin. Vitamin C, hindi siya na-store in the body kasi water-soluble na vitamin yan. So, any vitamin C that you take in excessively, tendency, i-urinate mo rin yan palabas. So, lesson for the day, wag nang mag-take ng sobrang vitamin C. Kasi sino makikinabang dyan? Yung toilet bowl nyo sa bahay. Yung toilet bowl nyo sa bahay ang makikinabang. Okay, pampalakas ng immune system, yung toilet bowl nyo ang magiging malakas ang immune system. So, therefore, para hindi sayang yung pera, wag na mag-take ng sobrang dami na ascorbic acid. No? Kasi iihi mo lang yung sobra niyan. Another important thing, although walang overdose ng vitamin C, it doesn't mean na wala siyang detrimental effect. Ha? Masama rin ang sobrang vitamin C. Kasi alam niyo ba na yung ascorbic acid na yan, kapag napunta yan sa kidneys, pwede yang mag-transform into oxalate. You can end up having calculi. Pwede kang magkaroon ng renal calculi. ng dahil sa ascorbic acid. So therefore, sabi nga nila, lahat ng sobra ay masama. So although walang overdose ng vitamin C, it doesn't necessarily mean na wala siyang side effect ha. May side effect ang too much intake ng vitamin C. It can cause calculi formation. So therefore, alagaan ang kidneys ninyo, no? Huwag niyo hayaang magkaroon kayo ng renal calculi, ng oxalate. So make sure mag-intake ng ascorbic acid on the right dose. Okay, right dose dapat. Okay? Pero either way, going back to the main issue, yan yung mga reason kung bakit hindi advisable si glucose oxidase as a reference method. Kasi aside from being too specific, they are affected by a wide variety of different substances. They're affected na by oxidizing agent, affected pa by the reducing agent. Okay, so therefore, sino pa rin ang reference method natin? Ang reference method pa rin natin ay si hexokinase coupled with your G6. Okay, so therefore, yan yung mga methods natin for the glucose analysis. Pero again, what we would commonly hear nowadays, or use rather nowadays, ay enzymatic methods, pero still try to be familiar with the different chemical methods natin. Kasi they are still appearing pagdating sa exam. Okay, so that would clear up the different methods and the different specimen requirements natin for the glucose analysis. Aside from that, ang nandiyan sa notes natin naman ay mga alin, yung mga conditions or hindi, yung mga laboratory tests. Okay, yan naman yung madalas nating na-encounter sa laboratory, RBG or the random blood glucose, fasting blood glucose, glycosylated hemoglobin, and so on and so forth. Kaso we really won't be able to tackle them anymore. Pero on the next page ng notes natin, nilagay na rin natin dyan yung clinical significance ng glucose natin, kung bakit ba tayo nagme-measure ng glucose. It is actually for the sake of diagnosing and assessing hypo and hyperglycemia. So nandiyan naman yung mga details ng hypo and hyperglycemia natin. So at least try to be familiar with them. Okay, the Whipple's triad, kung kailan lumalabas yung mga glycemic factors natin. Okay, so at least try to be familiar with those levels. By the way, itong mga levels na to, mga nag-appear yan dati ng board exam, no? Kaya I had to put that in your notes kasi mga dating recall question, yung mga values na yan. So you have to be careful with them. Okay? Apart from that, ginagawang Morse type na question minsan, ito mga characteristics ng hyperglycemia. So at least try to know or try to get acquainted with the different characteristics ng hypo at ng hyperglycemia natin. Okay, kaso we really won't be able to tackle them anymore. Pero more or less, that is the coverage ng carbohydrates natin. Okay, and then nandiyan naman yung lipids at saka yung proteins natin. Kaso again, due to the limited time that we have, we really won't be able to tackle them anymore. Okay, pero ayan. Nandiyan naman na yung mga details. Okay, hopefully, buti na lang na medyo nakompleto naman natin yung nakalagay sa proteins and sa lipids natin. Okay, so at least try to run through the different items that we have in there kasi hindi na talaga natin siya mako-cover. Okay? Pero that would conclude today's session natin. Okay, pasensya na, hindi na natin na-cover lahat. Okay, pero I do hope marami naman kayo natutunan during the lecture discussion natin. And in case na may question, especially kapag may discrepancy with what I have discussed and yung mga narinig, nabasa nyo sa libro, you can send me an email, okay, dun sa email address that we have there on the notes, okay, for clarification purposes na lang, no? Kasi minsan, iba talaga minsan yung nakalagay sa ibang libro sa mga nakalagay sa ibang libro. Pero most of what I have in there naman are taken from Bishop, Henry, and sa lumang libro, I use Calbret at saka Kaplan. Okay?